1, 2. Jeden, dva.
Okay, it works much better when turned on. Well, good morning, everyone. To all of you who are able to wake up in such an early morning, I would really very much like to know who the organizers are so that I can express my true feelings to them about such an early start of a rather important session. One of more interesting, well, all sessions are interesting, but I think, in my opinion, this one is rather hot, rather even controversial, if you like, in all aspects, in economical, ethical, legal, and so on. So I would like to introduce now our first speaker of the day, Mr. Sasha Vražić, who represents 50% of Croatian unicorn companies. He is from Rimac Technology, and he's leading the development of autonomous driving there. So I would kindly ask Sasha to give us his presentation.
Hello, good morning, everyone. So I will start. Some of you will have a chance to visit Rimac Technology or Rimac in general tomorrow. But for those who are not coming tomorrow, I will just make a brief introduction of a company. So this slide is just a representation of the automotive industry in Europe. So all the dots are supplier plants and the stars are assembly plants. And Croatia, which is the small part here, you see there's absolutely nothing. Until Mate Rimac started the company in 2009 in a garage, changing his combustion engine into an electric motor, and then start winning races with his car and gathering the money. He founded the company with the aim to create the fastest fully electric vehicle in the world, and also provide technologies to other partners. So that was in 2009, 0 employees, 0 revenue. And today, actually, we are about 2,500 employees. That's a certain amount of revenue. Beginning of last year, beginning of 2022, we carved out the company originally called Rimac Automobili into 2 companies, Bugatti Rimac, we'll say a few words later, and Rimac Technology, which is the supplier of a component. And this image that you see is one of the biggest projects in Croatia in terms of real estate. It's the campus Rimac is building close to Zagreb. Right. So 2 companies, 2 businesses inside the Rimac group. Bugatti Rimac, with the aim to develop hypercars. So very, very limited amount of vehicle, very exclusive type of customer, right? People who can afford vehicles above $2 million, usually. So here, so the aim of this company now is, of course, to produce all the Rimac vehicle, the Nevera, that we just introduced in the next slide, and all next Bugatti, the famous Bugatti brand, and their all next vehicles. And there's a part of a business, which is a different company called Rimac Technology, where the aim is to provide core technologies to car manufacturer in general. So the main focus is in the electrification, so providing full battery, axle, powertrain, but also technology like autonomous driving, control system, and such. So the Nevera is the world's fastest hypercar, fully electric and homologated. That's very important, because there's a lot of vehicles that are fast but not homologated. So we were wondering how we can help our customer to master this vehicle. This vehicle is very powerful. I would not say dangerous to drive, but you need to have some skills if you want to go above a standard way of driving. So that's why we're thinking how to introduce autonomous driving to support the learning of the drivers to master this vehicle. So we equipped the vehicle, and I hope you will be able to see it tomorrow in our plant, with a lot of sensors, and it's ready in terms of hardware. We wanted that it's ready for a full high level of automation. So we have 13 cameras looking all around the vehicle, using mostly stereo vision also. And we have 6 radars all around the vehicles, and we have a very strong computing unit. But we struggled also to equip with a LiDAR, for example, because we need, at such price, the design is very important. So you always need to compromise between the positioning of the sensors and the design. And for example, we couldn't package a LiDAR due to the design, right? So what is the product we develop with this autonomous driving? We call it the driver coach. Imagine the idea. So you own a car and you go on a racetrack where you need to master a certain amount of skills. So the vehicle recognizes the track and says, welcome on, I don't know, Silverstone, for example, in UK. And then the car proposes you, do you want that I demonstrate you what you have to do? And that's a fully autonomous demonstration. So you're on the track and you are totally guided by the vehicle. It's driving autonomously at a speed or performance that you can adjust as you feel comfortable. And while this is totally automated driving, you receive in your helmet, because on the track you need to have a helmet, a 3D audio feedback. So instructions, what the car is doing, all information about, for example, braking instant, steering instant, and so on. And you have also visual feedback on a cluster, for example, of a vehicle. When this lap or 2 laps are finished, for example, the session is completed, then the car can tell you, now it's your turn, show me what you can do. And during this time, our AI supervises the driver and analyzing the skills of a driver and classifying it through the beginner to a professional by looking at the braking capability, throttle, steering, trajectory, and so on, and of course the speed. Once the session is finished and we are able to classify you and find out what is your skill or your performance level, we can generate tailored training sessions. And you can practice and improve the skills exactly where it is needed while lapping. And you have another way to improve your skills, to go even further, is this live coaching, where you have dynamic coaching instructions that are depending on the performance you are driving, for example, the vehicle. If you are not driving fast enough, you may not need to brake in a corner, for example. So you will not have a marker that indicates you a braking point, or you will not receive an auditive instructions regarding any braking points. But it's also dynamic depending on your cognitive load. Meaning that if you are overwhelmed, for example, we will adjust the amount of information so you can still cope with what you have to do and limit the danger. And in the background of all of this, we have developed an active safety system that is for racetrack. So today, in all this autonomous driving element, you have, of course, the today it's deployed up to level 3, let's say, on most of the vehicle. Of course, robotaxis are level 4, still in testing, but you do not have this type of active safety does not work on a track. And I will say a few words about that later. So if we detect, for example, that you are not braking at the good instant, we will take over the control and brake for you. If you do not brake enough, we will give a brake boost, and the same is for the steering. And of course, we introduce a part of gamification that's engaging and analytics, but I will skip this part. So what do you think are the challenges that are for developing such autonomous driving, and how far are they from the road autonomous driving or level 4 robotaxi system? Actually, it's very similar. There are, of course, some difference, and I believe that although it's not the same target, what we're doing is also extremely challenging. So one of the aspects of the challenges are in the scene understanding. Scene understanding is understanding what is happening around the vehicle, but it's not only important to detect what are the objects, is to be able to predict the future. And that can be really tough, especially when you have some blind areas on a track. But also the localization. If you think that we are racing, you need to have a racing line. To have a racing line, you need to use all the width of a racing track. And for that reason, you need to be localized very precisely, usually below 10 centimeters or less. And for that, using the standard GNSS approach is not really working. So we took the part of working with camera-based localization system to try to solve that aspect, because we need to be robust to mostly any condition while you are driving. And the control and the motion planning, right? So you can imagine the scenario, you are alone on a track, so you can have an optimal racing line, but usually you are not alone on a racetrack, so you have a lot of other competitors. And Depending the strategy, if you want to really race, then you will need to dynamically compute the optimum strategy, which is always changing depending what is around you. And one thing that we really have headaches with is the safety metric. So, you know, on a road, it's pretty clear, it's well established, mostly about the safety metrics for road usage. However, what does it mean for racing, right? If you are too conservative, you are not racing. And if you are not conservative at all, you introduce a high level of risk. So there's a compromise here, and there's a totally different approach about the safety metric and understanding even what is happening and monitoring the behavior of opponents, I would say, on a track to minimize the risk. So the vehicle, it's not only sensors that you need to equip, but you need to make it possible that you can control all the elements. That goes from the steering, the brakes, and the powertrain. Right, so once you are able to control that, that's special parts of a vehicle and special additional software or supplier are needed to this high level of autonomy. And we are developing internally these 4 core technologies that I will pass in the next slides. So from the perception, the driver monitoring, the localization and mapping, and the motion planning. But just before going to that, it's how we develop. So we need data, right? And this data, we have a small fleet of sports cars that have a Kia Stingers, and we have our Nevera car. We have just one. Well, it's a very expensive car, but I'm very lucky. I'm the only department in the company who own a Nevera. So we can play with it on a track. And once we collect the data, we annotate them. But that's, you know, that's a heavy process. Another way is what we're using in simulation. While you use simulation, you can build scenarios and get the ground truth of the data automatically. Right? And we are doing software on the loop developments for all the core technologies. We're doing hardware on the loop to ensure that all the processing are executed in real time. And for example, we are also not allowed to put a piece of software in the car if it's not tested in what we call this vehicle in the loop. We have a big room where we have, I would say, the body of the vehicle and all the controllers inside the vehicle, and we can test a software. Of course, you cannot test autonomous driving in a room, but you can test all the interaction with the other entities of a vehicle and solve let's say the first problem in terms of communication and the first bugs, right? And then once we're happy, we are testing on real racetrack with our team of pro drivers. This is the racetrack that we visited. It's mostly in Europe, about 26 tracks. All the most important here this year. Still, by the end of the year, we plan to go to US, and early next year, probably to Japan. So, the perception, detecting the object. So that's one thing. So you can think, but what are these objects on the racetrack? And they are probably very different than on a road. Yeah, you have very similar objects. You have pedestrian on a racetrack, actually. You have vehicles, but you have roads, but you have things that are new, like the curbs. You have similar things like the poles, but you have racing flags, racing lights. You can have for example, a safety vehicle coming if there's an accident, and you need to be able to understand what's happening, especially when you drive autonomously, right? In terms of localization, so you see that's the same track, but taken at two different instants. You see also one, there's no cloud, weather is a little worse. And what I want to show here is just that we can track the feature between those elements to be able to localize us precisely below 10 centimeter. But mostly, as the task of mapping, it's quite an expensive task because you need to go on a racetrack. Usually you need to rent the racetrack for yourself, so it's pretty expensive. So one way we do the work is we work in simulation. And what you see here is the same track. On the left side you have a real world, and on the right side you have a virtual world. And you can see we can map some features and understand then where we are in this virtual world. So this, for example, help us for tracks, for example, for the Suzuka racetrack in Japan or Laguna Seca in US, where we do not need to go to map the track. We can either purchase the track and work on it, and once we are happy, we go on the track and we tune or finalize the development of the algorithm. In terms of driver monitoring, we are doing actually a lot of things. We're trying to understand the physiological and psychological status of a driver. So here what you see on the left side, the person were in the simulators. We collaborated with Leeds University. So we generated stimuli, visual and auditive stimuli, and we asked them to react, for example, to take the corners at a certain speed. And what you could see is, and we had two groups of people, professional drivers and amateur drivers, and here it's a professional driver, and you see that he didn't really behave well under certain stimuli. And this helps us to understand the cognitive load and then improve our user experience inside the vehicle and improve the safety also, because we know what type of instruction we need to provide at the right moment. But we, complementary to, or additionally to the test in a confined environment simulation, we did the same test on a real racetrack. We asked some driver, professional and amateurs. So this racetrack is pretty safe. We asked them to do the laps the best they could, and we generated stimuli. We asked them to double blink, you see, and they had to answer to some auditive messages. And we, using an EEG, we measured the cerebral activity and found out where are the negative emotions. We are very interested in negative emotions like anxiety, stress, for example, but also the cognitive load. So in terms of mapping, so we do some part of the mapping ourselves, because not all the tracks, for example, are available for purchase. So we use the drone, and thanks to the drone, we launch the drone all around the track, and we use the photogrammetry approach to create a model of a track. So that's the track that you saw before, and once we have this 3D model, we can integrate it into the simulator and drive the car, and then work on the racing line and so on, and make it more and more complex. So for example, this is a track we didn't go yet. It's Laguna Seca, but we're still already working on Laguna Seca. We drive the car. For example, in this situation alone, but in the next Next slide, I will show you that we can reproduce exactly what the car sees. So we model inside the simulator our cameras, for example, and we can generate virtual image, photorealistic image of what the car sees. So this is also in Laguna Seca, but here you see we have other vehicles, and we are working on avoidance or real racing algorithms. And why is this also important is by generating these images and using the simulator, you can create scenarios that you can spend years or maybe never caught by just driving and trying to collect this data, right? That's the age problem. And we use these virtual images to train our models, for example, mixed with real data. So in a mixed environment, and this improves all the algorithms. And when we are happy, here you see, for example, on a Stinger. So I will not show you it fully, but that's the racetrack that you saw before. For example, that's one of the tests. So the car is driving fully using the width of a racetrack, the full width. And what is important is working at the limit. Working at the limit means you saturate the tires. You take the corner the fastest possible, so you maximize the lateral acceleration. And by doing that, you are using the tires very much. And after, I don't know, 5-6 laps, the tire, the gum are damaged, and your brake also. And the autonomous system needs to understand when this is happening, because if you are not understanding that, you will use the same speed to enter in the corner, and then you will miss the corner. So you need to understand the degradation that is occurring in a vehicle, so you can keep lapping and lapping, and you need also to understand when, so this is, for example, the example on the Nevera. It's a little more impressive. So that's close to Zagreb. It's not a racetrack, but that's a proven ground that we own. And we reach this small straight line. One lap is 950 meters, and we reached the end of straight line at 170 kilometers per hour. So it can be scary, but here is just to show where we are in terms of technologies. And we ask ourselves a question, but where we are compared to professional drivers. And for that, what we did as an experiment, we selected 5 professional drivers. We asked them to go on the racetrack where we were developing. It was one that you saw some videos already. And we asked them to do 5 laps, continuously 5 laps, the best they can to get the fastest lap time. And they use the same vehicle as the one that is the autonomous one. And we did the same for our autonomous system. So the autonomous system here is the black dot. And what you can see, for example, here is we are second, right? The autonomous vehicle is second, and you see that in this corner we're overtaken by the pink dot, and then we are faster. So in the next lap I will explain that. And the blue driver is a killing driver. He won a lot of races. He's a champion. So at that point you see we cannot beat him, but what is important to understand is our AI system strategy was different in this final corner than the one from the pink driver. So when reaching this corner, the strategy of the pink driver was to enter fast and exit slow. And our AI decided to enter slow and exit fast. And that was actually a winning strategy because we could overtake him or be faster than him. And what you also see in this table is that at every lap, we improve our time. We stabilize, we understand the tires are getting hotter, warmer, and we improve our time. So we didn't win at the end, we finished second, but it's really a great result. And one other understanding is what we have is that professional drivers, after a certain amount of laps, they start doing small mistakes, right? Losing a little the stability of a car, or actually you're always playing with the stability with a car, so sometimes you are oversteering, the rear part is moving or understeering, while the autonomous system is still keeping the things constant. So we believe that if we did 10, 15 laps, we would finish first, and that's all VM here. So that finishes my presentation. Thank you for your attention.
Okay, thank you very much, Sasha, for your impressive presentation. I would like to now call our panelists. Well, in school we were called upon in alphabetical order. I will now just change that to counter alphabetical order, and I will ask Professor Kumare Sinha from Purdue University, who is Distinguished Professor of Civil Engineering and who's been active in teaching research and practice in transportation systems, planning and engineering for over 5 decades, and who is returning here to Croatia after many years to give his initial pitch.
So your presentation is this one, okay. You'll use this, okay.
Okay. I guess that's the reverse alphabetical order. Yeah. Well, thank you very much. It's an opportunity that when I was offered to me, I accepted happily because I came to Croatia several times in the past. First time I came, 1978, when Tito was still living. And then I came back in 1988. I was a Fulbright scholar in Yugoslavia. And then I also came 1992, but old Yugoslavia, but not in Croatia. I was in Slovenia. I could not come to Croatia because there was fighting going on. So I'm going to talk about what's going on in the United States, particularly, but when you talk about autonomous vehicles, we are thinking about not just autonomous vehicles in the context of electric vehicles, connected vehicles, and also some part of sharing how will be used. So my comments will be not just for autonomous vehicles, but all of them together. So in a short period of time I'll address few items, policy and planning, that we haven't done very well in that. The work is going on mostly on vehicles. You know, there are 3 things: vehicles, drivers, and roadway. Vehicles work is going on very well, much advanced. The driver, some extent, is happening, but not much on infrastructure. So issue is really catch on. We need to do better demand modeling. Then also government regulation to protect user safety, improve user trust. But that's all will go with how much we're maturity taking place, the market penetration of these kind of vehicles. Liability, better definition of liability, road use policy during the testing. It will be restricted use during that, like in San Francisco, that autonomous taxis being used in the night, although people don't like that because the vehicle stops when something it doesn't recognize, and people get mad because nobody can move it. It stops and sits right there. So also whether it will be used in dedicated lanes or certain roads. And also we have to think about that as autonomous vehicles come into picture, the rearrangement of urban land uses, like parking structures. Then, how does it go? Move to the next one.
Sorry?
Oh,
Okay. This one.
okay. And the biggest stumbling block of using autonomous vehicles is human factors. Perception. It's not the, when you give statistics, autonomous vehicle is this percent safer than regular vehicles, regular drivers. That doesn't help, because if you cannot control something, you're not sure whether you will use or not. If I can control something, even though there is a big risk, at least I'm in control. Leaving the control to a robot or somebody else is a different thing. So we'll have to have developed very detailed, much more in-depth, the cognitive type of science into doing research in human factors. There are several things are there. I will not go through, read these things. We need to develop a man-machine interface, and the risk characterization, also how do we measure them? When does human take over during transition phase? Warrants for takeover warning modes, those are the things that's yet to be done. And as I said, vehicles we're working on well, but drivers and other human beings and infrastructure. I'm a civil engineer. I feel there is a lot of work to be done in infrastructure readiness. And it will, of course, depend on market penetration of each LOA, level of autonomy in the transition phase. There are few examples I have. And highway agencies, they will not spend money to do anything until they're sure it is needed. So we need a better demand modeling. So all of these things have to work together. And then eventually, as the transition goes on, new infrastructure types we need, and also retire existing infrastructure types. My next slide, I'm going to pole vault over and go to the future. If it all pans out, this is going to revolutionize the way we live. It is going to, well, first of all, we all know why we are doing this thing, to make the safety, to bring safety, because you have to take the driver out of driving to make it safe, and also cut down the pollution, GHG emissions, travel efficiency. All those things will make sustainable mobility, and that will improve quality of life. And quality of life improves means there will be increased capacity of urban and exurban areas, including rural areas, to enhance human interactions. when people come together, idea sharing, innovation takes place. So I feel that the time is coming of a new kinds of human settlements, new era, that will provide socio-economic vitality, increase economic activities, job growth, and creative pursuits. We'll be able to save time from commuting and put that into do creative pursuits. Maybe enjoy museums, spending time with children. Life will be beautiful. So I feel if this all pans out, there's a promise of urban Renaissance, new kind of living, and all will be better off. Now, my last slide, few things that we need to do in the meantime is the role of us, the researchers and educators, rigorous empirical and experimental research, like our speakers spoke about things going on. We'll have to do not only the laboratory research, but ground truthing, rigorous ground truthing. Educational resources to reorient, retraining labor forces, coordination of universities, federal, state, and local government. They're all stakeholders, and private sector, of course, to implement implementation policies and development of protocols. Now, we are in the academies here, so I feel there is a need for international cooperative arrangements through national academies and also professional societies. Because, as I said, if it pans out, there will be revolution in the way we live. Thank you very much.
Okay, thank you, Professor Sinha. I would like to call now Professor Ivan Petrovic, who is a full professor of the Faculty of Electrical Engineering and Computing, University of Zagreb. He is the head of the Laboratory of Autonomous System and Mobile Robotics, and he is a full member of Croatian Academy of Sciences and Arts, and also a full member of Croatian Academy of Engineering.
Good morning, everyone. Thank you for invitation. Thank you for coming so early. So I will, in a few minutes, say some of my thoughts. My presentation is quite general because I didn't know what, not like what we are doing in the lab, but I hope we will discuss, just raise some points, and then we will discuss, I think, in the panel. Okay, about first, autonomous vehicle market size, just general information. So last year we have about 21 billion US dollar, and the forecast is that in 10 years we have about 2,350 billion US dollars market, and that means that the compound annual growth rate about 35% in 10 years. Which is really remarkable. But what are the market drivers for this to happen and to introducing it, at least at all autonomous driving, is first is safety. We know all that human error is leading cause of accidents on the roads. Then efficiency, autonomy and connected vehicles could really optimize, traffic flow could be optimized, and congestion could be reduced, and fuel consumption could be improved. But of course, electrification is also, electrical vehicles also could help in this. Accessibility, that means that we could also enable improve mobility of people who are unable to drive due to disabilities, age, and so on. Productivity, I think that the previous speaker just mentioned that we could enjoy the time in the car or we could do some work, entertainment, relaxation, spend, and so on. And also, cars, autonomous cars could also help in urban planning, the reduced number of parking space, improved land usage, increased focus on pedestrian environments, friendly environments, and so on. And what are the challenges behind those vehicles? There are a lot of technological challenges that technology should be reliable in terms both on hardware and software, and to be able to handle complex and predictable real-world scenarios. Of course, we are all aware of regulation legislations. There's a need for introducing legal framework for reliability, insurance, and safety, and also harmonization of regulations across jurisdictions between many countries in the world. The different culture, different jurisdiction. Also, I think that convincing the public, I think that you also mentioned before, that trust to autonomous technology. You mentioned this taxi and the issue of this acceptance. We are now in transition period in front of us. Transition period where we have conventional cars and we'll have autonomous cars. This mixed use scenario on the roads. That means this is really, it could increase, really have potential complications. I think the situation will be much more, let's say, easier, or when we have all cars will be autonomous in the future. And also cybersecurity challenges, because these new cars are connected and then highly dependent on connectivity, and that means vulnerable to cyber attacks. But also market opportunities. Introducing autonomous cars, new business models also will become possible, like growth of new service-based businesses, like sharing platforms, ride-hailing, of course, for new autonomous car. Autonomous car also could be a source of huge data for different purposes, like to improve urban planning, transportation systems, overall efficiency, but also could be used by governments or some companies for different optimization. And autonomous car will also, I think, give opportunity for new jobs, for economic growth, like new jobs in AI development, sensors manufacturing, because new types and a lot of new sensor improvement of sensors that we use, because this really bring new opportunities for fleet management, but also for investment in smart infrastructures. I think that was also mentioned. Also, electric car, but autonomous electric car in future really could have big environmental benefits. And for aging population, I already mentioned that mobility will be also, independence in mobility will be also enabled for elderly individuals. So just on one slide, how they work, what are autonomous technology behind. So different sensors. Sasha mentioned they do not use LiDAR because of the, let's say, design requirement, but also radar, cameras, even ultrasound. It depends, but also this car should be connected, wireless connected. Maybe in the future, I expect that this not only car-to-car communication, but also we have cloud, where we have map for the city, and also edge computing, AI also very important. This stages of autonomy levels, autonomous level stage 3, level 3 is, let's say, already, let's say, here, and now level 4 is approaching, and level 5 is long-term future also, but that when we have full autonomy, that means we can sleep in the car without fear. And here is some elements of from sensors, localization mapping, Sasha mentioned already, decision making, perception, of course, and object analysis, classification, detection, classification, tracking, and also I mentioned already cloud, where also cloud infrastructure and high performance computing will be very important. Here a list of topics for research challenges from, let's say, technical ones, more on the left, and also, for example, on the right up, you see simulate test environment. Sasha presented his presentation how they using simulation, a lot of simulations, and then interoperability, human-centered designs, all this. But this we could discuss during the panel or questions. But I will just put on the last slide adaptation to global driving conditions. There are a lot of challenges still in front. Let's say, imagine how autonomous car could drive here on these scenarios. It's really difficult. Heavy rain, you see people mixed with cars, cars that flood, very snow, very and desert with a lot of dust and so on. This situation is really, autonomy is the technology that really now, let's say, when you think about standard, as a EU city, okay, it could be bring, but let's think about situation, this complex, very difficult situation. Will we have autonomous vehicles capable to navigate in these scenarios? That also requires, what you mentioned, a lot of investment in infrastructure. So autonomous cars will require also investments in infrastructure, but this is also opportunity, creating new jobs and new opportunities. So this is all for the pitch, but then let's discuss later. Thank you very much.
Okay, now I would like to call the Assistant Professor Alexander Katriniok, who is with Eindhoven University, Control Systems Technology section, and he's been working also with the Ford Research and Innovation Center in Aachen, where he is involved in low-speed autonomy application. Alexander, the floor is yours.
Yes, thank you. Yeah, thank you very much. First of all, I would like also to thank the organizers, Nevin and Vedran, to invite me. It's a great pleasure, and also many thanks to Lukas to give me the opportunity to speak on behalf of ACTI, so the Dutch Academy of Technology and Innovation. Yeah, I'm basically working in industry and in academia, which is a great pleasure to me to see both worlds, to pursue new developments in the university with students, but also see what are the needs in industry. And I will focus a little bit more also on examples. We have seen a lot of challenges that are out there in automated driving, but we also have a lot of systems already on the road. And in your personal vehicle, you might have an adaptive cruise control system, a system that keeps the lane, right? These are more like level 1 or maybe level 2 systems where you combine longitudinal and lateral control. But recently, and I think Daimler is one of the first brands introducing level 3 autonomy, at least in Europe or the US, where you can really take your hands off the wheel and your eyes off the road for a limited amount of time. But you have, in a certain time period, be able to get back into the control loop. So the car tells you, hey, now I cannot handle the situation anymore. I'm out of the operational design domain, and now you have to take over again. But we see such systems already on the road, like the Daimler Drive Pilot, and more prominently, maybe even the Tesla Autopilot, which is not a level 3 system, but I call it level 2+, because the driver is still fully in charge of what's going on. So many might think, because of the name Autopilot, that's really a autonomous system, but it's designed such that the driver has still full control over what's going on. But we can also see level 4 or level 5 systems already on the road, like in the US. So Waymo, for example, it's a subsidiary of Google. has rolled out a quite significant fleet of vehicles operating in San Francisco, for example. Same for Cruise, which is a subsidiary of General Motors. And I mean, these systems are on the road, but some strange and interesting things are also happening. I don't know if you have followed the social media, but I also have one interesting report from the social media on my next slide. So essentially, what I wanted to say is that we have seen many technical advancements during the past years, and we have also seen in one of the previous talks that there is a huge market potential. This study is from 2019, maybe a little bit more optimistic than maybe industry would be today, but I think the message is the same, and we have seen it also in one of the previous talks, and I checked it, the numbers. Basically, this is the number of cars that is going to be rolled out in the market. The other slide was related to kind of the monetary perspective. But basically, well, we can expect 10 times the vehicles that we have in 2023, that we will see 10 times the number of vehicles in 2030. So there's a significant market potential for those vehicles. And we can already see many of them on the road, right? But one could say, well, what is still there to do? And we have heard it in the previous talks already. There is still a lot to do, not only from a technological or technical perspective, but also from a legal perspective. Ethics have to be considered. We have heard that infrastructure also needs to be considered. But also a lot of things can go wrong, right? We can see basically that cruise vehicles or Waymo vehicles are operating quite well. You can see on LinkedIn videos from influencers that call a vehicle, drive from A to B, and everything works quite nicely. But I like this figure here from Tesla, and it basically says it's all about the long tail. So what does it mean? Essentially, in many cases, let's say 99.99%, everything goes well, but there is a small percentage of cases which you don't expect and which can go wrong. So for example, in perception, if we have camera systems, the camera system is not trained that a bicyclist carries a stop sign. So there are very interesting pictures on the internet, you can check it out, where you can see cases that are not supposed to be trained in an automated vehicle. And the same is for motion planning and for every other domain. So we're still facing a lot of challenges, among of them, and I cannot count all of them, I just choose a few ones, maybe focusing a little bit more on the technical aspect. Our sensing and perception, I already mentioned it. I mean, what you can see is basically that these scenarios here where a car flipped over, there's a car on a trailer. There are a lot of things where an autonomous vehicle could draw false conclusions. We also have decision making and motion planning, which is quite complex. I see in industry that many approaches are still heuristics, right? And if you want, from my personal perspective, exploit the full potential, you may want also to look into optimization, into machine learning, and many questions arise also there. I mentioned before, we think that a lot of things have already been solved, but here is a post on X, formerly Twitter, where the robotaxis in San Francisco got stuck in one single road, and interestingly, there were like 30 or 40 vehicles of Cruise all in the same spot, right? And they could just basically get rescued by human intervention. So although these vehicles operate quite nicely in this environment, there is still a low chance, let's say a long tail of the distribution where there's a low probability, but there are a lot of cases that can go wrong. We also have compute power. If you want to apply more sophisticated algorithms that use machine learning or optimization, we have to solve those problems in real time, right? And also machine learning, I mean, that can significantly reduce your battery charge. So if you have to leverage a lot of compute power, what does it mean? We have 200 kilometers less in range. Is that acceptable? So how do we handle all those things? And that relates also to energy efficiency. But also, how do we combine decision-making and motion planning with efficiency aspects? What you can see also in industry is that many motion planning problems focus on the motion planning itself and not so much on efficiency. So there's also a lot to do, and we have heard it in the previous talks that legal and ethical aspects are of high importance. We don't have to forget the human, which is still there and which is a very important component of the whole control system, although the system might be automated. So for the upcoming discussion, I decided to come up with 3 questions that kind of move me the most in my everyday life, in industry, but also at university. And would also be very interested into to understand the position that Rima, for example, has in that regard. So how do we solve decision-making and motion planning problems subject to environmental uncertainty in real time and for serious production cars, right? As I said, in industry, for example, for autonomous parking systems, you see a lot of heuristic approaches still, but they cannot exploit the full potential. And so the question that I would like to raise is also, is numerical optimization combined with machine learning a game changer here? Or do many peers think that such methods are not tractable in serious production cars for many reasons? Also, how do we ensure that automated autonomous vehicle operation is efficient and sustainable? Because as I said, in industry, you see very frequently, and also in academia, predominantly a focus on how to operate the autonomous car to get from A to B, how to take decisions, but very frequently efficiency is not necessarily taken into account, and how do we combine these 2 aspects? And finally, it's a little bit of an overarching question. I think it was also kind of covered by the previous talks. I'm asking myself, how do we interact with the transportation system, right? I mean, motion planning kind of focuses on a single vehicle. A little bit selfish, I would even say. How do I get from A to B? But if I want to interact with the transportation system, I somehow maybe have also to sacrifice my own goals in order to achieve an overall improved efficiency in terms of traffic flow, in terms of energy consumption in a road section or in a confined environment. And also we can think about vehicle charging. So if I have electric vehicles, where do I charge them? How do I avoid grid congestion, for example, that I don't charge all the vehicles at the same time in the same place? So there are a lot of things that are still open, and with that I would like to finish my pitch. And if I may, just two points that I wanted to mention. If you're interested in these 2 topics, from an academical perspective, we have a special issue also on automated driving, and we'll have a conference in the Netherlands. Please feel free to reach out to me, and I'm looking forward to the upcoming discussion. Thank you very much.
Okay, thank you. And last but not least, Professor Subhasis Choudhury, who is with the Department of Electrical Engineering at Indian Institute of Technology in Bombay, and he is a fellow of all kinds of Indian academies that exist. Please.
Okay.
Thank you. Good morning. My great-grandparents kept a last name, thinking I'll have the alphabetical advantage. But since I'm talking at the last because of my alphabet in my last name, I think if you look at all the good things have been said already, and all the problems that the issues that need to be done has also been they've been mentioned. So what remains for me to talk on? Okay, so let's look at certain challenges that I would say. Okay, the first is a spelling mistake here, I see, because, okay. So if you look at the typical problems, I think, Sasha has given a very detailed description. So I need to detect the object, whatever Object means it could be the entire scene or whatever the part of it. Okay. And life gets difficult when you go in a city and others, there are a lot of glass objects and others. So we don't talk about that because then, you have reflections and others make life a lot more difficult. So, okay, so, coming to what Professor Sina said that, it's infrastructure also should be conducive to what you're going to use, right? So that's, you should look at that. Then there are like many cars moving. It's not just my life, there are so many other cars, everything. So how do you actually manage the relationship between different cars and others? Then of course we talk about at the car there, I have to find out where I position myself, what is the 3D environment, all of them, that's like SLAM, what is it called? So it's to be done, and these are all in real time, okay? Then what is, I think the last picture that you showed here, okay, was the inhomogeneous traffic. When things are moving in a very homogeneous traffic, similar kind of cars, others, okay? But imagine like, we talk about autonomous driving, and if you look at today, many of these DoorDash and other kind of delivery systems, they run, all of them are two-wheelers now. We don't talk about that, but the thing is that we need to change because that's where is our primary thing, and that works at a lower part of the income generation process. So they have to give a better perspective. So they should be the first one to go into automation mode, right? Okay. Then vehicle control, I think very nicely, I think is talked about in the last presentation. And then the stalemate handling. I think this is sometimes you have a complete stalemate. Okay. So these are the issues that need to be looked at. Okay. So in order to do that, I think in the first talk with the RIMAC, I think they said that they don't use a LiDAR. But the LiDAR is actually a lot more accurate, okay, in terms of data. And you can acquire data a lot more easily. But the problem is the cost. Okay, the cost goes up, okay, and sometimes if you want to reduce the cost, it's still about, I would say, $50,000 minimum, something like that, okay. Then what kind of system that actually fit in? Nowadays we talk about like CPU, GPU, FPGA, or whatever ASIC, different kind of thing. Now the reason I said that it has to be done fast, and people have talked about perception, right? So here we are talking about, let's say, level 5 or whatever, So in that case, you also need that latency is very important. How do you reduce the latency? Now, if you go for like CPU and all usage, then of course, latency would be very high. So you have to actually go into something which is like your GPU would make it faster. But what happens is that you have to pay a lot more in terms of energy, okay? So ASICs and others, so it's very specific to that. So the mass production capacity may be less unless you have, thousands and thousands of such things. But that's very important when you go for, autonomous driving. The heat dissipation. Now what happens is that if you use GPU or something like this, there is a tremendous amount of heat gets generated because they work at a high speed. Similarly, your car is parked and anywhere outside, on the sunny days, sometimes could be 40 degrees, okay, in centigrade I'm talking about, okay, or it could be much cooler. So in that case, this heat dissipation is actually one of these things is that this car has to be cooled, okay, and that means you have to actually, there is a loss of power. Because yesterday we had this battery power, when you talk about that. So we see that something like, up to 15% of your power goes into actually handling this. Okay, so this is completely useless in terms of your actual usage, but you have to do it, otherwise your system will start malfunctioning. Okay. Sometimes the Google map or something, whatever you are using, it's completely ridiculous. Once I was driving and I in an unusual place, and I said, okay, how do I go from point A to B? It took me somewhere, and then later on I find that it's actually for the two-wheelers, not for my four-wheeler. So I got stuck. I had to, so how do we know that this is safe? Okay, because finally it has to trust something, right? Now, building sensor redundancy. See, any kind of system that you have, okay, so we have some system redundancy required. Now, the moment you do the redundancy, now the system fusion level information that is required at the same time, your all this power level, computation time, everything goes up. Okay, so that adds like a cost to your system. Then of course, the ideal case is that nobody drives, it's all fully, level 5. Then they are all, I could have vehicle to vehicle communication. So that's definitely very good, okay? because then a lot of these problems get sorted out automatically. I don't need, to solve a lot of difficult problems, but the trustworthiness could be an issue because it can be hacked, and one injection could be a difficult one for, like a mass, collision or something like that. Okay. Then lane markers, many places, like even in India, you see that sometimes it's not there. Okay, so which is actually one of the good things for you to guide your, system. So you have to take care of that. Okay. Now also many times what happens that, there are traffic lights, it knows very well as of today, but sometimes because of construction and others, you put a traffic warden instead of light, and the system doesn't know how to handle that because there is a person who is guiding or left, right, or stop. It doesn't know that. So what is the after effect if you look at that? Okay. Now, autonomous driving, when you do, this reduces the battery power, because I told you like it takes about 15% or so. And this doesn't involve like redundancy. If you include redundancy, let's say even when you look at camera versus LiDAR, okay, so cameras, some of them are using simple few cameras, okay. Tesla uses, I think, 7 or so, and I think Rimac, I'm happy to see like 12 of them, right? So that's, but there's a price to pay for that, okay? Things become, of course, what he's talking about, fast and furious. I think that's the way to say that, okay? It's a good thing, but somewhere else I'm paying for it, okay? Now, many times what happens when you have a single lane system, okay, this is like, it doesn't know whether I am actually blocking a lot of other people because I'm at a slower speed or something that I can handle. And many times you know that you move to the curb and you let the other people go, okay? Which is a, good social behavior for us drivers. But this system doesn't know that, right? So it'll keep on obstructing the rest of the traffic, which could build up over time, okay? Now also, this leads to another issues that many times what happens that if any malfunctioning happens, unlike in human, okay, I know there have been cases that is reported while driving that somebody was driving a bus driver, okay, and the person had a heart attack, okay. Now when that happens, even if it's a heart attack, serious heart attack, you get, maybe a minute or so to respond, right? So there have been cases where they moved the car, okay, saved the life of another 50 passengers. But typically any electronic system, when it stops from, the malfunction happens, it's almost immediate, okay? So if something happens, then what is the recovery mechanism? Although, of course, we talk about redundancy, but definitely this is an issue that we should look into that, because the recovery, the safety cannot be compromised, okay? Then, of course, then car can become, the good thing, I think you talked about this, is basically the shared collective property of the community, rather than being an individual, which is very good because there's an optimal usage of our resources, which is definitely good. But there's another issue that happens is that finally it will not be only Rimac, there will be Tesla, there will be so many other cars that are there in the market, right? Now, when I go and I'm allowed to drive, there is something called driving license, driving test. So we have to pass that exam, right? So that I can be trusted to be given the license. Now, what happened, the licensing mechanism, that because I may come out in my lab and work out something and put that car over there. So what I mean is like it's a standardization of the system. So as of now, I don't see any kind of standardization that has evolved so that if your car actually meets this corresponding thing, then you are allowed to be on the road. Otherwise, you are not, okay? Because what you see in the SFO, the streets, these are all like an experimental demo pieces. They are not, they've been allowed, but when you have so many companies, you need to make sure that this is properly taken care of, okay? So I talked about, so that's like a certification, and other thing is I talked about the hacking part of it, because when everything is a level 5, is a connected network and everything, so how do you actually stop this one? But at the end of it, okay, so we need sometimes, somebody buys a car, somebody buys a big car, okay, fancy car. So what is it? Like finally is the fun of driving. We love the speed, we love the thing. Now supposing we leave it outside, of course there is a sacrifice we are making, but sometimes I think level, I think Rimac, you will allow me to drive on a regular mode also, so I should have that also. So that's definitely good. But what we are looking at is a world tomorrow where is connected, okay, where things are safe, where it is not like an individual, it's a collective system, and based on that, maybe we can have a system which is a lot easier to handle, and it will satisfy the needs for tomorrow. Thank you so much.
Okay, please come. It's time for the discussion. I don't know about you, but for me, this presentation were very interesting. Please sit. Where, Sasha? You are the main star of this panel. And just a question for you, when I mentioned your name. I noticed that on the steering wheel there was a KIA. What does it stand for? Killed in action? That KIA in your video on the steering wheel. Really? I'm curious. Is it a Kia car or?
It's really a Kia car, yeah.
Okay, so it was not Nevera.
No, we're using the Kia. Actually, it was a choice because, you know, we have shareholders inside Rimac that are part of Hyundai and Kia Group, so we could benefit of that by getting all the information how to control the car. Actually, we started this project, I can say, by hacking a Renault car, because we couldn't get the information from Renault how to control the car. But actually, so hacking was easy, but it's dangerous at the same time because you do not know what really the system is doing, right? You do not know what the state machine of a vehicle is doing, and you are trying to send commands, and we had some issues, right? When we sent a braking command and it didn't happen, we did not know why. So that's why we purchased the sports version of the Kia car, and we could get the easy access to control. Okay,
and while we're handling the mic, the Nevera, who is it made for? What is the purpose of the car? Is it for racing or is it for driving on the road?
Yeah, that's a good question, actually. And not everybody will race with a car, definitely. It's a car for car lovers, for collectors, for exclusive clients. It's a showcase of what the company can do in terms of technology. So you have the whole electrification. So it's the highest power density battery pack that is inside. So, and this actually made the company famous, and it's one of the biggest provider to all the automotive industry today, actually, and something we can be proud of. And it's the same for the other technologies like the powertrain, the infotainment, the autonomous driving. So the main idea is to provide that to supply others.
Okay, thank you. And one last question for you. Do you see the future in the racing of autonomous cars? I don't think that's very amusing. It looks to me like, for example, watching porn where robots are acting.
Yeah, well, actually the autonomous racing, it's an activity which is developing. And there's, I don't know if you are familiar, but for example, in Dubai, there's a Yas Marina racetrack, and there's a famous racing challenge where the first prize is $2 million, actually. So there's a lot of companies and a lot of work that is done, and the work, because also the work that we are doing here in Rimac and this technology that we are trying to build can be used for road and can help to solve, for example, emergency situation on a road where the standard approach of the manufacturer of level 4, level 5 system are not really considering such high emergency situation where you have, for example, for recently, a cruise situation where a pedestrian flew in front of a car and the cruise vehicle, robotaxi, couldn't stop and drove on it and then remain on the person, right? And maybe some emergency techniques in terms of control a vehicle could reduce this type of injury. I don't know, but the idea of what we are building, and university are a lot working into racing, autonomous racing. That's the Indy challenge in US. And that helps the community, actually, the scientific community and the industry to improve the algorithm.
Okay, thank you. Ivan, you are closest to the mic. You mentioned that this autonomous driving will create new jobs. Aren't you afraid of that FIST union of truck drivers in US who are capable enough to overthrow president of the States so that they might object about introduction of, what about all those Uber drivers, Bolt drivers? What will happen to them?
Yeah, that's also a concern. Okay, generally, every new technology really have two causes. One is that many jobs are actually disappeared, but new ones are created. So that means new jobs, as I mentioned, AI development. It means we need to educate people, new people on this, and then on sensor manufacturing. That's really, cars are really the main end user of for sensor technology companies, but now this become a little bit much more. The market will increase significantly because these sensors are more complex and more expensive than standard sensors now in the car. So also this is opportunity for new jobs, and for infrastructure we need also to build a lot of infrastructure work in cities and to enable this autonomy, to full capacity of the autonomy. And then, for example, this autonomous car actually could drive level 5 or level 4, level 5 in future smart cities that everything is connected. So that's, I think, open new jobs, but in different types of jobs. Yes.
Okay, and I'm glad that you mentioned urban planning for family reasons. I know something of urban planning, and I would say that at least here in Zagreb we are doomed. We should really switch to some other enterprise than autonomous driving, if it depends on urban planning.
Yes, please do.
Okay.
No, I think, I beg to differ to some extent the kind of thing that you were saying, because if I look at India, there's more than 10 million people who at livelihood depend on, this kind of transport system, whether it's a taxi or like, big vehicles, whatever. Now, suppose you say that I don't need them, maybe whenever it happens, then this 10 million people have to be shifted from somewhere, from this particular job to somewhere else. Now, if you say that the same industry, like if you look at generating this such kind of a technology that drives this, so definitely you don't need 10 million people to do this autonomous the system. So they have to go into creating some other kind of opportunities. So you have to have a complete different sociological, development in the system to say that these people can actually be done, because this is the complaint that today we get, that you have growth but no job creation. And that's whether we fall into the same loop again. I think that's what my comment is.
Yeah, I understand your concern. Actually, when you look back to this industrial revolution through time, it was that always the similar questions were raised. But I think that okay, maybe the fear is a little bit more have more sense now, because these changes are happening so fast. And then it's difficult if someone is 50 years old, and then difficult let's say, educate him, train him to be capable to do something else. That's true, but still, I think logistics, maintenance of these vehicles would change. Let's say, I don't know, a few months ago, I know that in Paul Zubak, one of our car dealer, they also opened a school for training new workers for maintenance the electric vehicles. And so I think maybe it's always a challenge. But what is the other option? Maybe I think that for future generation, if they are not trained in new technologies, then we will stuck in place. We need to go forward and find another option how to let's say, maybe people are not with 55 years old, if they can't be trained, we could some social measure introduced to help them, but not to stop the progress. You may, yeah.
You know, this fear of losing jobs in not just in transport area, automation, AI, you know, the film industry in Hollywood, the writers and actors, they're protesting. One of the things is AI, fear of AI. And then also in the automotive industry, the strikes going on, they are same thing, you know, they're afraid that electric vehicles will take their jobs away. This is exactly as he said, industrial revolution, Luddites, they're breaking up all the textile little spindles. But so, of course, there will be some upheaval.
I think it's a bit different. I think today in AI there is a lot more of A than I. I think that intelligence is not very you know the joke, I suppose, all of you. Mm-hmm. Well, if you are afraid that you'll lose your job to artificial intelligence, then your job didn't need any intelligence to begin with. And that person said, I didn't understand. And the other one said, you are safe.
Okay, that's a good point.
So, to continue, to leave, of course, some time for the questions for the audience, I would like to ask Alexander, he mentioned malicious people and how to handle them, those people waving a stop sign from the bicycle. And I can imagine a lot more pranks that evil people can do to electric cars.
Yeah, true. I mean, it was not in that case that I mentioned malicious, but of course, a lot of things could happen where people try to kind of, try to provoke that things are going wrong, of course. So, yeah, I think a lot of training is required in those systems. You have to find out what are the edge cases. And I think key will also be to collect data on the road, to feed it back into the cloud, to do some retraining, to feed it back into the car. I think Tesla has also done similar things in rolling out, for example, a cut in a prediction, for example. If you want to predict if a vehicle is cutting into your lane, what you could do is actually that you run such system in shadow mode. You validate your predictions based on data that you see on the road, and then you can see, hey, yeah, it behaved quite well, right? So I think what I wanted to say is essential is that you collect data, you feed it back to get really all those edge cases that you can face on the road. I think that's a key component to it.
Okay, and how far are we from solving this trolley problem? You know that one. Kill a bunch of people standing on the right-hand side of the road instead of a single person on the left-hand side of the road.
That's the ethical question, right? That the classical problem. I think, I'm not sure if this problem has been solved or can be solved. That's a really difficult one. You don't want to kill anybody. So in the end, I don't know. You cannot beat physics in the first place. Maybe you can establish a safety envelope that is kind of makes your system more robust to things that you cannot foresee.
but yeah, in the end, it's a very difficult question to say. I don't want to kill the one or the other person. I think that's not going to work out.
Okay, thank you. And Kumaris, you mentioned liability. Could you tell us how far are we from any applicable law in that area that will really regulate who is responsible for accidents caused by electric cars? Autonomous cars, excuse me.
Tell me, what's regulate the...
Yes, we probably need a law which will, unambiguously say, okay, Musk will pay for all those accidents caused by Teslas.
I still didn't understand the question very well. You're asking me who will decide liability? Yes, those are the things needs to be defined. It's not very clear. I think what will be eventually the manufacturer who will be responsible. I don't know, but those things to be defined. To be, in case of accident, who is liable? Is the company that provides the service, or the manufacturer, or what? Or the person who is riding the vehicle?
And what is your best estimate? How far are we from getting such a law?
I don't think we are, nobody's thinking about that yet. I do not think that anything is going on.
But we are thinking about putting autonomous cars on the street.
Right now, like Waymo taxi and those things, those who are the company, the Google, and they are responsible now for anything happens. But the way it is being done, like as somebody, I also mentioned, in San Francisco, the Waymo taxis in the night, they go around without any driver. But they're very cautious. Anything out of ordinary, the car just stops. And they cannot move. And the people don't like, but the traffic is backed up. So recently, one incident, a taxi got stuck in a firefighters. They tried to get rid of the vehicle out of the way. Nobody could move, and there is a central control, taking care. It takes about 30 minutes for somebody to come and move the car or do something. So the firefighters broke the damn thing and move it.
So this moves us to the second question that you mentioned on your slides. So this stalemate handling, how will we do that?
It's a stalemate, no matter whether it's a chase or anything. It's probably the big problem. So until normal mathematical sense, if you say that you need some external kind of perturbation to move it out of that stalemate, I think that would be the typical mathematical solution. But what is that extra thing that takes it out of that stalemate, right? So it's not clear, right? So for example, like here, what happened, that the traffic backing up and the stalemate that created. So finally there had to be human, interference in terms of moving it. Now, if you have interconnected vehicles, possibility, I think we have to look at the issue is that the system doesn't go into the stalemate mode, right? Of course, there could be always issues but if there is a connected vehicle, and also in tomorrow's thing, I can take an example, let's say, for example, in Japan, they have this bullet train, okay? And they have, they run at a tremendous high speed, right? And then they're very safe. And what is the reason? Because they created separate track and all these, the points that they have to maintain the standards. Now, here also, when you actually create, in order to remove such kind of stalemate points, I understand that cars have to be a little bit more on the defensive strategy that they would play, not like a fast moving car. But what happens is that we have to give a lot more sensors along the street side, other things, so that basically they get the feedback from there. And there has to be like a rebooting of the system so that you know that now I can start again. So unless that happens, that needs a lot of change in the environment variable in terms of how you create the, I think you talked about infrastructure, the civil infrastructure where there are at the roadside everywhere, there are markers, there are some kind of RFID or whatever the kind of sensors, right? So those kind of things have to be there so that you move out of that.
Okay, and one last thing. I think it was mentioned only by you on your slides, the fun of driving. I hope the manufacturers aren't planning of removing the steering wheel out of their vehicles.
Yeah, I think it's always, for young kids, they say that the few things they always look at is my first car, my first house, things like this. And I think ever since, the human civilization has come up with this, automobiles, I think it's a great fun for people to enjoy as long as you're a responsible driver. And I think most of them, they do. Okay, definitely. There are, of course, some rogue drivers. But that's something that, finally at the end of it, we talk about autonomy. But we have to live it a life which is also fulfilling and entertaining. Okay. Now, if I miss out now, you're going to miss out one part of the fun. I don't know, at some point particularly, I thought, oh, what happened? I mean, if you grow up with a culture that this fun never existed for the, the new generation, maybe they're okay, but for people like us, wow, at the end of it, I said, why not take a spin, go out, okay, have fun. So that would be missing.
Okay, thank you. So I think,
Can I comment on
yes,
that?
please do.
This is a very important point. The things have happened during pandemic.
Maybe a little bit
The
closer.
pandemic has taught us that it's not necessary for everybody to go to work, the commuting culture. Number one, that the automobile was used to go commute. And in particular in America, that I lived there for 60 years. That culture has changed. Not everybody, you cannot manufacture steel or do something that from home. But a good portion of the workers don't have to go to work. That's not that they don't like the office, but they don't like commuting. So that's one thing. Second thing, the new generation people, my children, when they're young, they're 16, they could have a license. They were eager to get license. My grandsons, they don't care. My grandson, 19, he doesn't care to have a license. So that driving is to be a big thing. It's not anymore. And some of my children, they live in downtown, they live in Central City, and they don't have automobiles. If they need the zip car or something of that nature, shared rides. So the world is changing, and so maybe all automation, the innovation that are going on, all put together, I envision that we will have, our living will change eventually, not today, gradually we are going towards that. That will allow us to live in close proximity to our neighbors and our neighborhood type of living that used to be 100 years ago. The fossil fuel fired automobiles destroyed the human scale of living, and that is going to be restored with that's my vision, that innovation in transportation, automation will bring us back to living in close proximity with our neighbors, and that will also cut down crime, and also it will add to conviviality and neighborliness. Life will be beautiful again.
Okay, thank you. So let's have some questions from the audience. Professor Barbir. And another one.
Yes, thank you. I really believe that this is the future of driving. However, before we reach this future, there will be a period where there will be both drivers on the road and the autonomous vehicles. And not all the drivers behave according to the rules. So I have an example, actually a couple of examples. I lived in Istanbul for 3 years, and I know how people drive in Istanbul. And they have a rule, if you want to make a right turn on a highway, you don't drive in the right lane, you drive in the left lane, and then at the very last moment you cut and go to the right. So I'm pretty sure if there are autonomous cars in the right lane, they will never turn right because all the people will be passing them going on the left lane. And another example is I worked in a shipyard where there is about a few thousand cars on the parking lot, and they all want to get out of the parking lot as soon as possible. However, that requires a lot of skill and a lot of aggressiveness to get out as soon as possible. I'm pretty sure that the autonomous vehicle will be the last one exiting this parking lot.
Okay, thank you. So it was more like a statement than a question. Do you have really a question for our panelists? Lucas. Who is next?
So this is a question for Sasha. My name is Lucas Nolders from the Netherlands Academy of Technology and Innovation. Thank you for your fascinating story. While we were speaking, I sent a picture of one of your slides to my sons in the Netherlands, and he immediately responded with, Rimac is amazing. Rimac is the absolute dream. I'm so jealous.
Thank you.
That you're going to visit their factory tomorrow. But that aside, that's not my question. So I was impressed by the sensors that you showed related to driver monitoring. So the EEG headset, the eye tracking, say that is very relevant to the situation that you were sketching where the car will have dual function. On one hand, it's an autonomous vehicle that demonstrates to the driver what the car is capable of, but then the sports car hands over to the driver because you don't buy a 2 million euro sports car and not drive it, right? You want to be on the steering wheel. So you do see a permanent role for the driver there. In, say, mainstream vehicles, we see the arrival of built-in driver monitoring sensors, such as eye tracking, which are becoming mandatory due to European legislation. Do you see this type of sensors and, say, even more advanced cognitive load monitoring devices being built into your vehicles, into the production vehicles, and becoming part of the commercial car in the end? Or is this a temporary deployment in the research phase?
Okay, thank you first for your comments, and yeah, that's a good question. Of course, our vehicles are for drivers, right? You do not put such type of money to not drive. We just want to find a way to support the enjoyment of driving, right? To have fun and to master the vehicle. But when you look at that in terms of technology, it opens the possibility to a lot of other companies, because most of the car manufacturer has a sport division, and some car manufacturer has racing in their DNA. So there's applications to other companies of such technologies. Regarding the driver monitoring, yeah, we use it for two purposes. One is for teaching, for example, understanding where is the gaze, right? Understanding if there's some drowsiness, for example. That's a safety issue, but understanding where is the gaze, we can use it for teaching. For example, while you are driving, we can teach you that you need to look at the second corner and not the one that you are driving into, right? And then ensuring and giving you a feedback in the helmet if you are where you are looking is right. But at the same time, you have this safety scenario where if you pass, if you close your eyes too long, if you lose attention, we will automatically take over. So that's a safety. And there's a lot of applications in a vehicle in the future, and that's mandatory for level 3 and and level 4, level 5. It's a different thing, but yeah. So, but that will be more called cockpit monitoring than just driver monitoring. But yes, the application is not only for research, but for products.
Well, thank you. Are you also using these, say, eye tracking techniques for a user interface designing the dashboard, instrumentation and displays, and evaluating what is the optimal way of presenting car information to the driver and where to present it. Because I see an interesting development that, say, classical cars have all the instruments behind the steering wheel, so you look through the steering wheel at your odometer and your the rotation, the acceleration meters, whatever. Modern electric vehicles often have a large computer display in the middle of the car, in the center of the car, which force you to look to the right in order to read all that information, which inherently means a loss of attention to the roadside view. So it's a more tricky human system interaction than the classical simplistic displays behind the steering wheel, where you didn't have to take your eyes off the road in order to read your, say, your fuel level. What is your take on that?
If you can answer briefly, Sasha, please, because we are already in our coffee time. I think Professor Mana is patiently waiting for his question, so if you can be brief. So one more question and then we are done and we are going to have a coffee.
Yeah, very briefly, there's a
answer.
lot of work into this area, as you mentioned, I'm aware of. We are not particularly in Rimac working on that aspect, but I know there's a lot of work in terms of user experience inside the cockpit, yeah.
So
Okay.
in a racing competition, let's say the car which wins is made by your Rimac. So who gets the prize, the driver or the company?
Yeah, very good point.
No,
But actually at the end is the driver, right? Because the autonomous labs are just to help the driver to understand what he has to do. So he keeps his hand on the steering wheel and he feels the torque while cornering and so on. But at the end, he's driving.
So, well, in that case, if it were the other way, then apart from 10 million driver in India, the likes of Vettel and Schumacher, they also would go jobless.
Yeah.
But there's a reason why I'm asking this. See, in case of electric vehicles, we all are aware why we are going for that. So for any change, there has to be a reason why, a motivation, why we are going for a change. So in case of autonomous driving, is it safety that's the biggest driving force, or what exactly is?
Yeah, you can see us bringing active safety at a high speed, right? Which is not what most of the companies are working on today.
Okay, thank you very much. Please don't run away after the panel. I think people will like to ask some questions during the coffee time. I think this discussion was very interesting, at least for me, and we can continue in the lobby. Thank you.
I think there was enough time for a coffee, and we are about to start our fourth session, session on hydrogen, fuel cells, and electrofuels. I will follow the same structure as was in the previous panels. So first keynote lecture, and then initial pitch of panelists, and then of course discussions and questions from audience. So our speaker today is Professor Frano Barbir from University of Split, Croatia. He's Professor Emeritus and in the same time employed as project activity leader at Center of Excellence at the University of Split. He is involved in hydrogen and fuel cell technology, research and development, engineering, application management since 1980s, working in United States as researcher manager in industry as well at universities. We also heard that he was working in Turkey as Associate Director of Science and Technology of International Center for Hydrogen Energy Technologies. His research interests are related to PEM fuel cells, heat and mass transfer in fuel cells, effects of operational conditions, performances, durability, design, and so on. And he has co-authored more than 300 papers, as well as 8 US and European patents, and a very famous textbook about fuel cells, which is translated, for example, on Chinese, Korean, and Farsi, and it's used at many universities worldwide. Currently, he's Vice President of International Association of Hydrogen Energy and Croatian representative in the States Representative Group of Clean Hydrogen Partnership. And of course, member of Croatian Academy of Technical Sciences. Professor Barbir will talk about hydrogen in transport. Professor Barbir, please.
Thank you very much. Everything here is on the slide, so I can skip immediately on the next slide, which gives the outline of my presentation. I would first like to give some history of hydrogen and fuel cell vehicles, because we can always learn from history. Then give a current status of hydrogen and fuel cell vehicles. I would like to compare fuel cell electric vehicles with the battery electric vehicles. And at the end, I will attempt to predict the future role of hydrogen and fuel cells in transportation. I think it's very much clear that a hydrogen car is also an electric car. It has an electric motor, but the energy is stored in the form of hydrogen instead of any batteries. But I should also mention that every fuel cell car is actually also has batteries, so it's kind of a hybrid car as well. We can also have a hydrogen in internal combustion engines, but I think that's already passé, although recently there are some advancement in internal combustion engines, but the efficiency of fuel cell systems is higher than the efficiency of internal combustion engine. And efficiency should not be compared at the maximum power, it should be compared at the average power, and there the efficiency is about twice as much in the fuel cell vehicles than in internal combustion engine. So most of the recent developments are in the fuel cell electric vehicles. Now going back to history, the first hydrogen car was developed 1807, and it was in France. This vehicle used the first internal combustion engine that used hydrogen as the fuel, and hydrogen was stored in a balloon. And this vehicle is now in a museum. And then a few decades later, the fuel cells were invented. Actually, the Swiss-German scientist Christian Schönbein is the first one who realized the fuel cell effect, and he was in communication with Sir William Grove as well as with Faraday, and those letters are saved, and they prove that Schönbein is actually the one who first observed the effect of fuel cells, but the Grove was the one who first made a working fuel cell and applied for a patent. Then again, several decades later, we have a remarkable prophecy by Jules Verne, who made many predictions, and many of those predictions came true. And so this one about hydrogen being a fuel of, or as he said, water being a fuel of the future with its constituents, hydrogen and oxygen, is also coming true. For me, another remarkable prophecy is by Friedrich Wilhelm Ostwald, who is the father of physical chemistry, who also more than 140 years ago realized that the energy conversion in combustion engines is limited by Carnot efficiency, thus has a very low efficiency, and creates unacceptable levels of atmospheric pollution, unlike the fuel cells that are direct generation of electricity, highly efficient, silent, and no pollution. He predicted that transition would be a technical revolution, which we are starting to see now, and the prediction was the practical realization would take a long time, and indeed, it took now more than 100 years. Between two wars, there was a lot of development of hydrogen vehicles by a German engineer, Rudolf Ehren, who worked both in Germany and UK, and he also has some patents in the United States. He made dozens of buses and trucks running on hydrogen using internal combustion engine. And then in 1993, Norsk Hydropower Company converted one of their small trucks using hydrogen engine, but the hydrogen was not stored on board. It was ammonia that was stored on board, and there was a small ammonia cracker on board the vehicle. And then about 100 years after the fuel cell was discovered, we had the first practical fuel cell. It was by Francis Bacon in UK, and that was just before the Second World War. And then after Second World War, this technology was obtained by US company and used in a space program. But this was the first fuel cell system. And then very soon after, we have a first fuel cell vehicle. It was Alice Chambers' farm factor that was developed in 1959. This tractor is now in Smithsonian Institute. And then we have a space program where they use not only hydrogen as a fuel for propulsion, they use fuel cells in both Gemini and Apollo program. And what is interesting, in Gemini, they use PEM fuel cells, which are now actually predominant type of fuel cells. But at that time, they were not very reliable, so they switched to alkaline fuel cell based on Francis Bacon invention, and they use them both in Apollo and Space Shuttle. And that was actually the beginning of a new era in development of fuel cells for practical Earth applications. First, in 1966, General Motors developed this van, which is considered the first fuel cell power vehicle. And then Professor Carl Kordesh, who at that time worked for Union Carbide in the United States, converted this car. You can see the hydrogen tanks on the roof. It looked funny, but he used this car for 3 years for commuting, going to work, back and work in Boston. Later, he came back to Austria and was a professor at the Technical University of Graz. And in 1993, a Ballard company, which is now a well-known fuel cell company, created a fuel cell bus. And just about a month later, a company in Florida called Energy Partners made the first PEM fuel cell power passenger car in the world. I'm proud of this because I was a part of this team that developed this car, and you can see me this in the middle of this, look at this tall guy in the back with a mustache and with the black hair. By 2000, every car manufacturer has developed at least a prototype, and some of them even a fleet of vehicles. And then in 2014, I was in, I think, medical waiting room waiting for a doctor, and then I passed through those magazines, and one of them was Popular Mechanics, and in that there was an advertisement for Hyundai. That was 2014, and the title was the first mass-produced hydrogen car. So Hyundai actually started selling those cars in Korea. A year later, Honda was leasing these cars in California. It was called FCX Clarity. Mercedes had developed even before Series B in a small production. They had a world tour with these cars. And then in 2017, they came with the idea of first a plug-in fuel cell vehicle, which does make sense, but they actually never realized this because in the meantime, they changed the CEO and they changed the policy and the strategy. So the first commercial fuel cell car is Toyota Mirai. Mirai in Japanese means the future. So this is the car of the future that Toyota developed. Ankita will later show you some more of this picture. This is the newest model of Mirai. They have a business model selling cars not only to individual customers, but also to the taxi fleets, for example, in Paris and in Hague. I had a chance to watch a video on YouTube about a taxi driver praising this car. He said, this is much better than the batteries for, if nothing else, than for a very fast refueling. He said, I spend only 5 minutes to refuel my car and I'm back on the road with the customers. And the newest model is again Hyundai Nexo, which is also being sold in Korea, and later you will see the most cars now in the world are sold in Korea. So this was taken from a magazine, the hydrogen cars in 2023. There are only 2 listed. So there are basically 2 car companies that are selling fuel cell cars. If you want to buy a fuel cell car, you only have 2 options now, which is a Toyota Mirai and Hyundai Nexo. And the price is about $60,000, and they are even rated here on the right side. But recently, earlier this year in May, we had a conference here in Zagreb organized by Ankita, and there was a BMW with a new car, iX5, and they are entering in the low volume production. I had the chance to drive this car. This brings us to comparison between electric vehicles with the fuel cells and those with the batteries. Yesterday we heard several times the battery cars are much more efficient than the fuel cell cars, therefore we should use electric cars with the batteries, not the cars with the fuel cell. And there is no question about it. The batteries from well to wheels about 70 to 90% efficient. The fuel cell cars about 30 to 40% efficient. So there's about 2 to 3 times more efficiency if we use batteries instead of fuel cells. But efficiency is not the only criteria that we should compare the cars. There are many other things that the final customer will actually decide on. For example, refueling time. The fuel cell car can be refilled in 3 to 5 minutes, while the battery car can refill about an hour or more. Then energy density in terms of size and weight. Hydrogen itself has about 40 kilowatt hours per kilogram, but efficiency of fuel cells is about 50%, so we get about 20 kilowatt hours per kilogram electricity. If we include the tank itself, we come down to 0.7 to 0.9 watt hours per kilogram, because in the hydrogen tank we only have few percent of hydrogen by weight. And if we include the fuel cell itself, then it's about 0.4 to 0.6 in the present systems. In the present systems, the batteries are 0.1 to 0.26, the highest one I saw on the market. So there is an advantage again of 2 to 3 times in terms of gravimetric power density in favor of fuel cells. And what is important there is a separation of power and energy. In the batteries, power and energy are in the same device. In the fuel cell, the power is in the fuel cell and energy is stored in the hydrogen. So if you want to extend the range of these vehicles, you don't have to add more fuel cells, you add just more tanks. And those tanks have a gravimetric power energy density of 0.7 to 0.9, which is 5 to 6 times more than the batteries. So the larger the vehicle, the more energy you have to store on vehicle, the hydrogen becomes better and better. But then again, there are many other things that should be compared. Safety of fuel cell vehicles and hydrogen, and safety of batteries. There are very few studies about this. Usually, the researchers and the companies don't like to publish papers about failures, but there are failures I've seen the fires of batteries, I've seen the fires of hydrogen vehicles, so that has to be studied and published also. There is a performance in extreme conditions, extreme heat, extreme cold. There is also performance loss over time and durability of both fuel cells and the batteries. And there are, we heard also yesterday about the materials constraints and the recyclability that applies to both the fuel cells and the batteries. But finally, the owner or the potential customer will make his decision basically about the cost, and that's a lifetime cost, not just the purchase of a vehicle, but also a lifetime operation and the cost. Automotive companies are making their plans for the future, and usually they make maps like this. I believe this is a General Motors about 10 years ago, and they believe that the battery vehicles will be for small vehicles with a light load and a short driving, but for a longer driving and a higher load, the fuel cells becomes more and more interesting. There is a similar slide by Toyota, but I'm pretty sure that Ankita will have this slide as well that shows the same thing. So on one side we have a traveling distance, on the other side we have a vehicle size, and we see that for a short distance and small vehicles, batteries are better. For a higher, the fuel cells become more attractive. Besides the passengers, that becomes more attractive for the buses. This is a chic program that was running between 2010 and 2016 in Europe, and there was also 10 buses in Canada. Overall, 26 buses were tested in 7 EU cities. This program was continued with the 3 motion, where another 29 buses were tested in between 2015 and 2022. And then the program Jive 2 and the Merlin tested both the vehicles and the infrastructure. Excuse me. And we had an opportunity to test one of those buses here in Zagreb. In December, we had one Caetano bus that was used by ZET, the Zagreb Public Transit Authority, and it was tested on the routes that are extremely difficult, for example, for batteries going to Sljeme and going back, and they were testing the hydrogen consumption. There was also a refueling station improvised in their facility in Podsused. And then there are plans for additional 1,000 hydrogen fuel cell buses along with the supporting infrastructure in European cities. And these numbers are still not high as they should be, because you should know that China is producing 1,000 fuel cell buses a year, and we are talking about here in a 5-6 year program in Europe. So we are lagging behind. I had a chance to work on one of these projects on a fuel cell bus. We were actually developing a fuel cell range extender to the battery electric bus. Company was VDL, the largest manufacturer of electric buses in Europe. And we were quite successfully built this system. It was led by Bosch and Erwin Klinger. And by the time we were making these pictures, I was strolling around their yard, and I noticed those trucks. Those were DAF, label was DAF, and they were hydrogen trucks. So the same team that was working on this project was also working on these trucks. And the team from Bosch, after this project was over, they flew to Arizona because Bosch bought shares in the company called Nikola that is making hydrogen trucks. And this left picture is from May 2018, when they announced that they have ordered for 800 hydrogen trucks. And just last week, actually yesterday, I found this on internet, that the Nikola's landmark launch of its hydrogen fuel cell trucks in North America. And it's not just the trucks, because you can build as many trucks as you want, but if there is no refueling infrastructure, that's useless. So I know that Nikola was also working with my ex-company that I work for, Proton Onsite, which has been bought by Nel, now on establishing at least 200 refueling stations along the United States. Hyundai also came with a fuel cell bus and claiming they have a customer in Switzerland who ordered 1,600 trucks. A similar announcement came from a company called Hyzon. When I checked this, those are mainly ex-General Motors engineers. They have an order of 1,500 hydrogen fuel cell trucks in New Zealand. But the big players like General Motors are also developing a heavy-duty hydrogen fuel cell truck, Volvo as well. And then again, recently they made an announcement that the customer testing will start in 2025. But on this slide, we have American company Kenworth working together with Toyota. They already have trucks ready for the road. And no wonder the trucks are actually more successful, because this study performed for the Clean Hydrogen Partnership showed that the hydrogen buses, and those are those with the blue lines here, are very much cost competitive, and cost means the total cost of ownership with the other technologies, and also very close to the existing diesel buses. And in 2027 and 2030, they are even the least expensive option. So to summarize the latest news on hydrogen vehicles, you can find any information on Google and internet today. So the number of fuel cell vehicles in the world increased by 40% only in 2022, totaling to 72,000 vehicles. About 20,000 vehicles were sold in 2022, and only 15,000 of them were cars, and 2/3 of these cars were sold in South Korea. About 80% of the global stock are cars, with 10% being trucks and almost 10% buses. The fuel cell truck segment grew at a faster rate than the cars and the buses, increasing by 60%. And what is interesting, China is home to more than 90% of the world hydrogen trucks and almost 85% of the global fuel cell bus fleet. And there are about 1,000 hydrogen refueling stations in operation around the world, and about 200 in Europe. Hydrogen is also very interesting for the trains. There is a Alstom train that is running in northern Germany. It's actually in service already, and the Siemens is also developing, excuse me, a hydrogen train. For 2 weeks ago, we had a conference in Zagreb here about hydrogen on trains in Croatia, in the Ministry of Sea and Transport and Infrastructure. And the purpose of the conference was we have in Croatia opportunity to use such trains because these trains are especially cost competitive on non-electrified lines that are longer than 100 kilometers, and they have less than 10 trains traveling on those. And we have such a line between Zagreb and Split, actually between Ostarije or Ogulin and Split, that is not electrified, and it will never be electrified. So there's an opportunity for Croatia as well. I did mention hydrogen refueling stations. There's about 1,000 of them in the world, 200 in Europe. Those are pictures of some of them. And this is a map of how many are there in Europe. I said about 200 so far. And that brings me to the study that was performed by Jülich Research Center in Germany that compared the infrastructure of batteries and the infrastructure for refilling the hydrogen. And the conclusions actually show in this picture below, and shows for the low volume, the battery infrastructure is cheaper because it relies on existing power plants and existing lines. But in the future, for the same amount of vehicles on the road, the fuel cell actually infrastructure may become even cheaper. And here are some of the conclusions of this study. So for low market penetration levels, a few 100,000 vehicles, the cost of infrastructure low route are essentially the same for both technology. Hydrogen infrastructure is found to be more expensive during the transition period, but for a high market penetration up to 20 million vehicles, a battery charging infrastructure would be more than a hydrogen infrastructure. The mobility costs per kilometer are roughly the same in the high market penetration scenario. And for the scenario with 20 million fuel cell vehicles, approximately 87 terawatt hours of surplus electricity for electrolysis, and the emphasis here is on the surplus, plus 6 terawatt hours of grid electricity for transportation are required. On the other hand, charging 20 million batteries electric vehicles accounts for an electricity demand of approximately 46 terawatt hours out of the distribution grid. And then also while preparing this presentation, I came up to this study that was performed just last year that tries to, for me, very realistically estimate the effect of batteries and fuel cells. And on this small graph here, you see actually these are the existing vehicles, and then the batteries are light blue and the fuel cells are dark blue. So small percentage of vehicles on the road will still be fuel cells. And it will take me more than allowed time to actually explain all these graphs too. But the conclusion of this study, we need both infrastructures, and it'd be cheaper to have both infrastructures just to try to have just one of them. So coming to conclusion, there are issues with hydrogen for transportation. First of all is competition with batteries. But for me, actually, there is no competition. There should be actually just market sharing. Different market segments can be covered by batteries. Different market segments can be covered by hydrogen vehicles, because hydrogen fuel cell electric vehicles have 3 major advantages that I already mentioned. That's a separation of power and energy, gravimetric specific energy, and the fast fueling. Also, the other issues that are actually preventing a large-scale hydrogen deployment is a hydrogen production from excess renewables. Hydrogen makes sense if it is produced from excess electricity. And we heard also yesterday there will be a lot of excess electricity once we go to the 100% renewable energy systems. We will need 2 or 3 times more installed power than what we actually need to satisfy just the power requirements. And that excess should be used to produce hydrogen, and that excess, of course, will have a very low price. So that will also reduce the price of hydrogen, because right now hydrogen is relatively expensive. And of course, there is no enough infrastructure, because we still have there a chicken and egg problem. Nobody wants to build a hydrogen refueling station, because in order to be commercial, they need at least 200 vehicles on a daily basis to fill the hydrogen there. And nobody's going to buy a hydrogen car because there is no hydrogen infrastructure around. And then at the end, I promise I will attempt to predict where hydrogen and fuel cells offer sufficient advantage to make significant contribution to decarbonization of transport. However, I have a warning here, because predicting the future is a risky business. This is how 50 years ago the scientists from a Rand Corporation envisioned the home computer will look like in 2004. And we can now all laugh. So I don't want 50 years later people laughing at me and say, Professor Barbie said in 50 years we will drive hydrogen cars such and such. And also there are some other remarkable prophecies here by experts at that time. IBM chairman said that he thinks there is a market for maybe 3 computers in the world. And the president of Digital Equipment Corporation in 1977 said that there is no reason why anyone would want to have a home computer. They couldn't be more wrong. So I hope with my prediction I will not be that wrong. So my prediction is that the cars, hydrogen will be used only for those customers that find fast fueling important. Buses depend on the route configuration, available time for refueling and recharging. For example, the route that goes uphill, the hydrogen is probably better than the batteries, because the batteries will be empty by the time the bus reaches top of the hill. Similar goes with the trucks, depending on the route length and the configuration and available time for charging or refueling. Trains, probably for regional trains on longer non-electrified routes, as I already explained. I didn't touch ship and ferries, and I believe my colleague Rodolfo Taccani will talk a little bit about ships and ferries, but only for shorter routes. For longer routes, probably ammonia or some other e-fuels will be better. And for airplanes, there is still discussion. There are studies from back in the 90s, and there's a recent one by Airbus, and before was by Boeing. Hydrogen is the lightest fuel of all. It's 3 times lighter than other fuels, so that's very alluring for aircraft. But hydrogen tanks are heavier, so at the end, the hydrogen may be heavier than other fuels, but it certainly is very attractive fuel for airplanes. And the last, so I predict that the priorities for decarbonization of transport should be, first, electrification with batteries or catenary. Hydrogen will be used in segments where electrification is not possible or feasible, or where hydrogen offers some other advantages or convenience. And at the end, e-fuels produced from hydrogen, because don't forget, e-fuels are produced from hydrogen. So if you use the argument that hydrogen vehicles are less efficient than the battery vehicles, then we should also use the argument that e-fuels are less efficient than hydrogen, because e-fuels are produced from hydrogen. But there are still segments where hydrogen is not possible or feasible, and where the e-fuels may offer other advantages, such as, for example, in ships and airplanes. And with that, I would like for your attention and draw your attention to my recent book that I just got a copy before I came here to Zagreb. It's called Fuel Cells for Transportation, exactly as the title of my presentation here today. Thank you very much.
Okay, thank you very much, Professor Barbier. So we will have enough time later on to discuss about open questions. So our next panelist is Professor Tomasz Katrašnik. He's full professor of energy engineering at University of Ljubljana, Slovenia, and scientific counselor at National Institute of Chemistry at the Department of Materials Chemistry. He's also head of the Slovenian research program Energy Engineering and president of Technical Board of Slovenian Strategic Research and Innovation Partnership Mobility, as well as leader of Sustainable Energy Pillar of Slovenian Strategic Research and Innovation Partnership for the transition to circular economy. His research is focused on multi-scale modeling of batteries and fuel cells, as well as on electric, hybrid fuel cell and conventional powertrains, internal combustion engines, thermochemical processes, alternative energy vectors, and so on. So, Professor Katrašnik, please give us your initial pitch.
Good morning to everyone. Thank you for the invitation and thank you for the introduction. So since I knew that Professor Barbier will address this topic very holistically, I will just focus on one smaller part, which is the role of advanced observers in maximizing performance and safety of fuel cell systems. So Professor Barbier already talked in general terms about this. So there are also some safety issues, durability issues. And let's say, if we look now to such a let's say, renewable energy system. So we can see here, let's say, fuel cells, electrolyzers. So I will today talk about the fuel cells, but the same is valid for electrolyzers. If we go further, we can see that there are some electric vehicles connected, so fuel cell electric vehicles connected to it, sorry. And if we then dig into it, in the fuel cell electric vehicle, we see fuel cell stack. In a fuel cell stack, we see a fuel cell single cell with channels. Here you see membrane electrode assembly. And if you go deeper in, you then see membrane catalysts, and already here we are on micro or nanometer scale. And fuel cell works only if all these processes and all these scales work properly. And certainly, which is unfortunately the case, the fuel cell is, except for first few moments, all the time when it operates, dying. This does not mean that it's useless, by far not. This just means we have to take care how we operate it, and we have to know what happens inside. And as said, to master this, we need to cross much more scales, let's say, that were previously encountered in transport with internal combustion engines. And so, why this is so important, let's say this is some basic graph. You see steady state operation, so this is fuel cell degradation, so performance degradation, and you see here various transient operating conditions. And so you see that various transients decrease significantly the lifetime of a fuel cell, also potentially its safety. And the harsher the cycling, the shorter its lifetime, and it's also depending on the profile. So idea is, if we want now to maximize return on investment or durability or use minimum of precious material, it's not just important to produce a cell, but it's very important how we operate it. Therefore, also we have in fuel cell electric vehicles the battery, that we minimize this phenomena. So how it degrades, so these are now really atoms. These are a few sketches. Let's say we have some carbon surface oxidation, so where the catalyst is on carbon support. Platinum can dissolve. It can go from small particles to larger particles. You see here we can burn off carbon support, and also the membrane could be attacked from some radicals, just to name a few of them. Then if we look on slightly bigger scales, we are still, you see in 100 nanometers, you see here cracks. So here is the membrane, here is the catalytic layer. It might crack. We might get pinholes, and this is then already a safety critical event. At the end also, since all particles grow, we will have less platinum, we will have lower performance, fuel cell will produce more heat, and then certainly we should identify this. And then basic ideas are now in the cars. So here's a car, we will have kind of fuel cell management unit, which is currently not that complex, but it will get more complex in the future. And here are these advanced observers and virtual sensors. Why they are important? Because we cannot install all physical sensors, but we still want to see in the fuel cell. And what we need for this, so we need physics-based or mechanistic models, we need some observer frameworks, and we need then parameterization tool. We have to identify if we have parameterize it, and we have some model-based DOEs that we can really look competently into it. And yes, all of a sudden we are then talking a kind of digital twins which will run with us. Some of them will be in a car, some of them will be in the cloud. So this is still currently under development. And let's say how it will look like at the end is that we will have real unit under test. We will have some inputs, and in parallel, models will run which will compare outputs of real system to outputs of the model. And with this, then we can do a lot of identification and see what's happening. So here I will only show some brief results, and with this I will end. So these are the values that were measured in Professor Barbil's lab. So you see here quite heavily degraded fuel cell. Then we put a model on it, we parameterize it, and then all of a sudden we can look inside the fuel cell. You see, we can see how much the intrinsic exchange current density has changed, how much ohmic resistivity, how much diffusivity. So this gives us the quality of the catalyst. This gives us information on the membrane. This gives us information on the GDLs. And yes, we have also validated this, and you see the model prediction coincides well with what was then experimentally measured. And here the main message is that advanced model-based control monitoring, and in particular diagnostics, which is not yet developed very well, is key to ensure high efficiency and durability of electrochemical devices, fuel cells, electrolyzers, but the same is also valid for batteries. So for greening, we also need a lot of digitalization. So thank you.
Okay, our next panelist is Professor Rodolfo Taccani. He's Prorector for technology transfer at the University of Trieste, Italy, and full professor of power plants at the Department of Engineering and Architecture. He was president of the Italian Thermotechnic Association since last year, and his research interest comprised the analysis and optimization of energy conversion systems with particular reference to fuel cells and hydrogen. Currently, he is a member of the joint working group of the North Adriatic Hydrogen Valley. So, please.
Thank you very much for the presentation, and thank you very much for inviting me for this opportunity to give this presentation. Well, I want to start from something that Professor Barbier said earlier, and in particular that to increase the number of hydrogen or green vehicle we need in infrastructure, we need more green hydrogen, and we need to reduce cost, because today we know that hydrogen is very expensive. So for this reason, one reason that in our macro region, I'm talking about Friuli Venezia Giulia, Slovenia, and Croatia, the Hydrogen Valley was started, the so-called North Adriatic Hydrogen Valley. And I will tell something about this Hydrogen Valley. So a way to develop an ecosystem for the complete value chain of green hydrogen. But 2 words about the University of Trieste. So maybe some of you knows already, it is a medium-sized university with about 20,000 students. But more than this, it is part of the scientific and innovation system of the Friuli Venezia Giulia, a network of 17 research institutions with the aim to boost the result of scientific research in terms of socioeconomic benefits. What is the Hydrogen Valley, the North Adriatic Hydrogen Valley? It is a hydrogen valley that encompasses 3 territories: Friuli Venezia Giulia region in Italy, North Italy, Slovenia, and Croatia. In particular, one of the first steps of this hydrogen valley ecosystem is the development, a proposal submitted to the European Horizon calls that was successful and started in the 1st of September. So we have now a Horizon Europe project running with the same name, North Adriatic Hydrogen Valley, that encompasses 27 partners, 5 research institutions, and 3 public institutions. And the overall value of the project is about 350 million euros. Well, as I said, an hydrogen valley includes regards all the value chain of green hydrogen, starting from green hydrogen production, for example, from photovoltaic, from wind turbine, then transformation of green electricity to green hydrogen, and utilization. And this is an important aspect of an hydrogen valley. So utilization is not only for mobility, but it is also for industrial processes, for the so-called hard-to-abate sectors, such as steel industry, cement industry, glass industry. And then we have let's say, heat and power application and mobility. Mobility, but as Professor Barbier said, where fuel cell and hydrogen finds a better way of utilization, it is probably the so-called energy-intensive mobility, such as trucks, as we saw before, and shipping, propulsion of ships. And this is what I will address a little bit more in the later. Well, just to say that this North Adriatic Hydrogen Valley was quite a long process to establish this ecosystem, and because it was recognized by the public institution. And it was, in my opinion, a perfect example of international, of transnational collaboration. As you see, here are the territories involved. In particular, what you see here, there are the pilot project of the European project, of the Horizon Europe project only. And there are other projects that will be developed. But these that you see here are the demo case of the European project. The way of transportation of hydrogen will be mainly compressed gas, but it will be also studied the possibility to transport the hydrogen in liquid form and through a pipeline. But what I want to point out is that our territories are on the sea. So shipping is one key aspect in Italy and in Croatia. So therefore, part of the project, and here is the list of the pilot project that will be activated in this Horizon Europe project, regards also shipping, propulsion of ships with hydrogen and fuel cell. Well, one of the projects that will start first, it will be a green hydrogen production plant in the port of Trieste. And again, the application of hydrogen for green shipping is coming out. It will be a 2.5 megawatt electric electrolyzer, and the electricity will come using a photovoltaic plant with a peak power of 4.5 megawatt. And also part of the waste treatment plant electricity that is coming out from burning, from oxidizing the waste of the town, will be used also to produce hydrogen. And as you see here, this Hydrogen Valley project regards the utilization of green hydrogen for the industry, for the hard-to-abate sector, but also for transportation, and in particular, as I said, for high energy-intensive transportation, such as trucks and shipping. Why shipping? Because shipping, we know that it produces about 3% of the total greenhouse gases overall. So it is not a big amount, but it's very concentrated in coastal area and in particular in ports. So you can imagine a big ship that is entering the port of Dubrovnik, for example, of the port of Trieste. It has an installed power of tens of megawatts. So it pollutes as 1,000 of cars. So the idea, and here I am presenting just as an example of some of the projects that, let's say, the Friuli Venezia Giulia side is carrying on utilization of hydrogen in shipping. So if we can decarbonize shipping, we can actually improve the quality of the coastal area. But as we saw earlier by the presentation of Professor Barbier, the internal combustion engine has a low efficiency for small installed power, for part load operation, but in the case of ship, an internal combustion engine of a bigger power output can have an efficiency up to 50%. So you see that the fuel cell can be competitive, but there is not a clear, let's say, clear winner of if the engine is a fuel cell or it is an internal combustion engine. So therefore, this is one of the key aspects together with the hydrogen containment, and we are thinking about other hydrogen carrier, for example, methanol or ammonia. So in the future, it is very, as Professor Barbie said, it's very difficult to see, to foresee who will be the winner. But anyway, the International Maritime Organization set a clear limit in the emission of shipping as well. So we want in 20 years to go almost to zero carbon emission in shipping. So in the next year, it will be very interesting to see what will be the technology development. But by sure, electrification and utilization of hydrogen also in shipping, especially in short route, will be interesting to keep under consideration. Thank you very much.
Our last but not least panelist is Professor Ankica Kovač from University of Zagreb, Croatia. She's head of Power Engineering Laboratory and founder of Regional Hydrogen Energy Conference, as well as the editor in the International Journal of Hydrogen Energy. She designed the first Croatian hydrogen-powered bicycle and installed the first Croatian hydrogen refueling station. She worked a lot on the advertising of hydrogen transportation, and together with company Toyota, she organized the Croatia Mirai Challenge as the road trip from Zagreb to Brussels. Professor Kovač is member of the executive committee of the collaboration program on advanced fuel cells, where she is official representative of the Republic of Croatia, and also she is member of the Council of the President of the Republic of Croatia for Energy Transportation and Vice President of Croatian Hydrogen Association. So, please.
Hello, everyone. Good afternoon. As you heard, I'm from University of Zagreb, Faculty of Mechanical Engineering and Naval Architecture, where I'm a leader of hydrogen group, and we are working amazing things, and we are involved in amazing projects. But today, on behalf of Managing Director Krešimir Bago, I will give you a short overview of Toyota Croatia, and not just Toyota Croatia, but Toyota in a global. Why we are all here? I think we are all here and we are discussing about transportation, and not just about transportation, is a climate change. Climate change is the most important question of our era, and we need to focus on solving this issue, and I think we are all on the good path, not just in the carbonization of transport, but on the carbonization of all sectors and on involving new technologies wherever we need and we can. So it is important to speed up the process and to use all technologies without CO2 emission, and to not take them about competitors, but to take everything we have on the market to reach our goal of climate neutrality by 2050. So what does Toyota work? Toyota gives a huge effort on the decarbonization of transport, and not just in their own company for producing vehicles, but also for producing fuel cells in collaboration with other companies for the tracks and for backup systems at some large data centers. So Toyota has started very early. We have their work in dating up from 1992, where Toyota started to work on a fuel cells and on this technology. And today we already have a second generation of Toyota Mirai, and here in Croatia we had a great opportunity to host first generation during our Croatia Croatia Mirai Challenge, as we heard, a road trip from Zagreb to Brussels. And also last year in November, December, we had the opportunity to host Toyota Generation 2 and also Caetano bus where Toyota worked with Caetano in developing this bus. Toyota has a multi-tech approach. Their opinion is that there is not only one solution. As I had already said, we have to take everything good that we have on the market and to use it for higher goals. So they have fuel cell electric vehicles, hybrid electric, plug-in hybrid electric, and also battery electric. As we already saw this sketch, Toyota Sustainable Mobility Strategy is developed globally, and depending on the state, on the requirement, they offer on the market the solutions that state required. They are very much focused on building a hydrogen society. That is our common goal in global. There is often a dilemma that we are talking about when we have some discussion about what was the first hydrogen vehicle or what to build first, hydrogen vehicle or hydrogen infrastructure. These two technologies has to go together. So by involving hydrogen vehicles, we in parallel have to work on introduction and installation of hydrogen infrastructure to supply existing vehicles, personal vehicles, tracks, trains, or whatever we have. So we have to go together all of these technology so we can put everything on the market. That is why Toyota developed a one-stop shop model, so bypassing CAPEX for cities. They are collaborating with numbers of partners on different stages. So it is not just the point to buy and pay for the vehicle, but there is behind the whole strategy and technology and a lot of work. So we can drive on hydrogen in transport, in industry, or wherever we want. Public transport is a hot topic, and many cities are working on introduction of hydrogen fuel cell buses. Today we have cities that already have in commercial use hydrogen buses, but numbers of them are promoting clean transportation based on hydrogen. Toyota is a part of these projects in different cities across the Europe, and also Zagreb had the opportunity to host hydrogen bus in November, December last year, we had the opportunity to be a part of this unique project across the Europe, and to test hydrogen buses in all of our environment. So we also went to Sljeme, and it was amazing. It was snowing, and I think the best photos within this project, Jive 1 and Jive 2, has been sent from Zagreb because of the atmosphere. You have snowing, and you have a fuel cell bus, and you really have a feeling that you are doing a good thing. So you are driving in, you are a part of transportation, but without pollution. You feel on peace. I'm clean, my environment is clean. I think it is a really good feeling. Thank you very much.
I would like panelists to join me here. Yeah. Hydrogen is really nice, but I would like to start with safety. So Professor Barbier, just point out few, let's say few words about safety. What are issues?
For leak of hydrogen is the highest among all the fuels. But the consequences of that leak are probably least than other fuels. So in many aspects, hydrogen is, I would say, at least as safe as other fuels, but in some aspects even safer. And if you click on the internet looking for the hydrogen safety, you can find the photos of back in the 1990s when I was doing my PhD at the University of Miami. Professor Mike Swain was doing with his group a safety test, and he had a force focus with gasoline and force focus with hydrogen. They drilled the hole in a tank, both of hydrogen and the gasoline, and they ignited and both, and then they filmed everything. And you can see those films there. The gasoline car, because gasoline is heavier than air, gasoline goes on the floor, and when it ignites, the whole car was engulfed in flames. But the hydrogen flame from the tank went straight up, and it lasted 90 seconds, and after that, it was extinguished because there was no more extinguished, and there was no more hydrogen in the tank, and the vehicle was safe. Interesting, this 90 minutes, because anybody knows here about the Hindenburg. Nobody's alive here when Hindenburg happened. That was in 1937. But that is actually proof how safe hydrogen is, not how dangerous. People use this to show how hydrogen is dangerous. First of all, that didn't explode. Second, hydrogen was not the cause of fire. The fire was caused by the lining on the Hindenburg. And when the fire happened, of course, hydrogen ignited, and the flame lasted 90 seconds. And it was long as 3 football fields full of hydrogen, and after the fire was gone, it went down. And 62 people survived this accident. 30 people, I think 32 died. Some of them died because they jumped from the gondola, and some of them died because they were close to the mechanical room that used diesel fuel. That ship used diesel for the fuel. So that's actually an example how safe hydrogen is. There are several features that I can talk hours and hours about the safety, but hydrogen is at least safe as other fuels. That's what I would say.
Thank you. Let's move on the common things which are related with use of hydrogen. Let's say so, storage, transportation, production. Can you give a comment on it? I think the part of this initiative in North Adria was related to the transportation by pipelines. So how efficient is transportation by pipelines in comparison with other kind of hydrogen transportation?
Thank you. Yes, transportation of hydrogen is still a complex and difficult challenge, because as you said, transporting hydrogen costs energy. So even if we compress it or we transform it in liquid form, it is part of the energy content of hydrogen is lost in this process. Just to make an example, to compress hydrogen in a pressure vessel up to 300-400 bar, we lose, depending on the type of compressor or the process, 5% of the total energy that we store. And at the same time, if we want to liquefy hydrogen, we lose 20% of the energy. So the problem of transportation is very complex. One way is a pipeline, and we know that in Europe we are talking about that. In Italy also, and there are feasibility studies to transport hydrogen together with the natural gas in the pipelines, but up to a concentration, not 100% today. So today, for example, according to the SNAM, that it is the company that transport natural gas in Italy, the percentage of hydrogen that we can put in natural gas is some percent, up to 10, 20%. But again, we have a fuel that contains carbon, not only hydrogen. So the next frontier is to develop pipelines for pure hydrogen, but this is something that has to be done from the very beginning. At least to the knowledge we have, one pipe that is used for natural gas cannot be used today for transportation of pure hydrogen. Therefore, the transportation of hydrogen remains a big issue, and therefore other way of transporting hydrogen with hydrogen carrier is under investigation.
Okay, thank you. Professor Katrashnik, let's move to the start, hydrogen production. So you was talking about problems with catalyst, platinum, and so on. What is the current research on different materials? You are working in the Department of Materials Chemistry. Is there any way to supplement material which is used in fuel cells? And is there any other ways to produce green hydrogen, for example, dark fermentation or biological processes? What is about these technologies and what is the state of the art?
Thank you. Very complex question. I would dare to say that, currently we have many technologies to produce hydrogen. Also, if you go to electrolyzers, you don't have only one technology. Let's say it could be solid oxide, you could be a PEM. The challenge is, as low as you stay in a low temperature, which means smaller units, which means units that are not fully transient capable, but more prone to cycling, you are then currently still non-platinum based catalysts do not yet perform well. So you're stuck with precious metal, whose price is quite high. If you go, let's say, already to solid oxides, certainly they are not all abundant materials, but at least you have no presence of platinum, which already quite significantly decreases this pressure. But yes, as you said, electrolysis is maybe currently the main source of hydrogen because we start with green electricity. And so this is how also comparisons that Professor Barbie was addressing start. So we start with electricity or in the future green electricity, and then we compare. Certainly biological processes are competitive, and I think also they will be in the future for sure have some market share. But let's say at least if there would be no breakthrough in technology also in this area, currently if we look in overall energy demand, not only for transport, but overall, it does not seem to be feasible that we will be able to produce a very significant amount. So take saying half of this energy by biological processes, but this does not mean that a significant share or the share that we can maximize should not be exploited. And I'm very much looking forward to also these alternative processes. And also in that respect, also the hydrogen as an energy vector, I think it's for sure a viable one, but also due to the fact, as Professor Barbier addressed, on one side there are, let's say, if you're on transportation batteries, on one synthetic fuels, there is for sure a share for hydrogen, but since we have three competing processes, it's maybe less well defined for now because also the infrastructure is not there. But therefore, I think it's really important that we come up with the production of green hydrogen, which then also boosts LCA analysis, and also, as said, if we don't go for hydro energy, which is storage and green energy at the same time, but if we go to solar panels, wind energy and others, for sure we already now see negative prices of electricity, or let's say we disconnect solar panels and stuff like this, which is from an energetic point of view not reasonable. And if this part of this energy or higher share of this energy would be stored in hydrogen, this will also have economical effects and economy of scale effects and stuff like this. But I think this is now really ramping up. Europe was, I think, stacking behind Japan and China, but with now all these projects on hydrogen valleys, research projects, start of productions of fuel cell vehicles, I think we will now get momentum in this area.
You notice that in the North Adriatic Hydrogen Valley, we have at least 3 projects that intend to produce hydrogen from waste. So that's also, waste is not renewable energy per se, but it can be provide additional amounts of hydrogen, because that solves 2 problems. In Croatia, we didn't solve the problem what to do with the waste, and now we can solve the problem with the waste and also with hydrogen. And there is also another possibility, not to use the noble metals like a platinum, iridium, but there are also electrolyzers that can use other catalysts, and Ankica can tell us for alkaline, they can use nickel. Yeah. So there is, we are not limited only to platinum.
Okay, thank you. Professor Kovac, what is with infrastructure? So I saw on the Professor Barber's presentations some graphs related to CAPEX, and I'm not sure about OPEX. Can you give a comment on it? Can you compare CAPEX and OPEX of hydrogen or for hydrogen vehicles and for competitive car type of vehicles?
Okay, thank you. I'm not the expert in CAPEX and OPEX, but I can give the opinion about general hydrogen infrastructure. It costs, yes, we have a high cost from investment and further in installation, but no one said it will be cheap. So I think the point of financial point for national question should not be the only reason to give up of hydrogen infrastructure, because for example it is currently much more expensive in comparison to battery for the station for electric vehicles for batteries. But if we, as I said, if we want to see more hydrogen vehicles on the road, we have to go with installation of hydrogen infrastructure, and this is something what is written in directives AFIR. So we will be in obligation to install hydrogen refueling station every 100 kilometers in around urban cities and TNT corridors after 2030. So I think it is better to start earlier, rather earlier than later. And this is the reason, hydrogen infrastructure is the reason why we don't have more hydrogen vehicles on the road. So these are technologies that I already said has to go in the parallel. I don't know who is the expert in CAPEX and OPEX, so maybe you can give the opinion about it. I smartly switched off. Professor?
Yeah. Any comment on it? Or
maybe I can do a few comments. I think it heavily depends on the size and technology. Let's say recently we did some projects in the defense sector. If you are on a smaller scale, certainly it's currently much more expensive than other competing technologies. But let's say also there you have to consider other benefits. I think, you know, there they go to the resilience, then they go to on-site energy vector production, and so there are multiple benefits. Which not in all sectors are present, but why I want to address this, that it's not wise to operate with a single number across the fields. So someone should really always look in specifics of a case, let's say some, I don't know, some island populations, some specific use cases, and there certainly these are best promotion scheme, promotion spots, where then you further develop technology, economy of scale goes up, prices go down, and I think this is the wise approach, not just saying currently it's more expensive, it's not viable. I think this is very wrong. So now giving a single digit that's valid for all around the world is not good. And also another thing is, when someone will build renewable energy system, there will not be one size fits all. If someone looks to Norway, certainly their renewable energy system in the future will look very differently, like in Croatia, like in Slovenia, like anywhere else. And someone should not just take the numbers over there, someone should really go into specific of the energy sector, calculate its own case and then see what are the benefits. And I think this is very important, not to just transfer the numbers.
Thank you. Professor Takani, you mentioned different kind of fuels which could be used in ships in 20 years, and you didn't predict future. You just well mentioned, okay, we should change it, but how we will do it? On what will be the choice? Can you try to predict at least? We will not make quotation or citation on what you will say now. In 20 years or 30 years. Yeah.
Yes, thank you. Well, I want to start with an example, with an experience. Around 2010, liquid natural gas was considered a fuel, an interesting fuel for shipping. Not all the shipping community was convinced on that, because it was really a difficult challenge. Shipping is a sector where safety is at first, so having a fuel that has a low flash point was a problem. Anything lower than 60 degrees Celsius was not allowed on board. So think about flammable gas was something really almost impossible. Okay, at the end, 15 years later, LNG, liquid natural gas, is used on board. Ships sail, come to Trieste. I imagine they come to Dubrovnik as well. So you see that the technology issues can be overcome. Well, in that case, obviously there was the pollution problem. So the International Maritime Organization set some limits for sulfur, for nitrogen oxide, and so liquid natural gas could offer the possibility to meet these new limits, lower limits. But then the driver was another, that LNG was much cheaper than HFO, than the other fossil liquid fuel that were used on board. So the ship owners, for the ship owner was quite easy to decide. Okay, I install LNG because the operation cost will be lower. Well, with hydrogen and hydrogen carrier, the story is completely different. Obviously, we can benefit from the experience of using a cryogenic fuel on board, such as LNG. So the way to install liquid hydrogen on board will be easier. But again, we are talking about 100 degrees Celsius of difference, or 100 Kelvin. So liquid hydrogen on board is still very difficult. But today we have, for example, a ferry on a short route that sails using liquid hydrogen. So you see that this technology gap somehow was covered, and today we have this ferry that sails on liquid hydrogen. And we have other ships that today sails on methanol, for example. Methanol, it is easier to use. Internal combustion engine can be used, and so therefore I think that on shorter route hydrogen is a very good candidate, but for big ships such as a container ship on longer routes, maybe other hydrogen carrier can be developed or can be used. And at the end, what I see is that probably that there will be a mix of different fuels depending on the specific application.
Thank you. Professor Barbier, is there any real space for trains on hydrogen? So trains which are using hydrogen as fuel?
Yes, absolutely. As I said, even now, presently, on the lines that are longer than 100 kilometers and not electrified, it's cheaper to use hydrogen train than a battery train. Again, it also depends on configuration. For example, for this road from Split to Zagreb, we have a very high steep at the very beginning. So if we had a battery train, it will deplete all the batteries by the time it came to Labin, which is only 10 kilometers away from Split, because it's a very steep. So there is a probably for combination of those, but I'm pretty sure that the hydrogen does make sense for this from Ostaria to Split. There is another line from Koprivnica to Osijek that is also not electrified, but that one is much easier to electrify because it's in a plain terrain. And then there is another one that is shorter than 100 kilometers, but very interesting for a touristic reason, and that's in Istria. They have a train in Istria that is now not even functional, but that could be revived and use hydrogen and use green hydrogen as an advertisement for green Istria.
Thank you. So I think we are now ready for a few questions from audience. Is there any? Yep, please.
Thank you for the interesting presentations. Hydrogen production by electrolysis from water has been mentioned several times. That's a viable source. When that is done, oxygen is a co-product. What are the thoughts about using the oxygen effectively as a co-product?
Okay, I can give the answer. Currently, the market for oxygen is huge. And when you look at the analysis of hydrogen power plants and how to produce hydrogen by water electrolysis and using renewables, you will see that a return is much faster by putting oxygen on the market. We have industry that needs oxygen for the processes, but also we can use it in medicine, in fishing, and there is a really huge market, and this is a good question. Usually people forgot on oxygen during the analysis, but there is the money. So for investors, when you do such analysis for designing hydrogen power plant, you should also give the analysis of hydrogen, of oxygen. I had the opportunity to make pre-feasibility study for one huge company, and my team suggested them to do analysis of oxygen, and they told us, no, we don't need oxygen. We said, but think one more time because there is a market for, no, we don't need it. And days after, they called me and said, okay, please include oxygen analysis. We searched the opportunities and the internet and the current status, so we did it. Thank you for this question, it is important.
So as said, yes, for sure, what was said is okay, and there will be oxygen market, but also if you look for stationary application, if you already have, let's say, oxygen and hydrogen, and if you have fuel cell, you might use this oxygen in a fuel cell, thereby you at the same pressure increase the partial pressure of the oxygen, which means that if you want to gain high power, you don't need the energy for compressing the air, which increases efficiency of the system. But also if you go to combustion related devices, be it gas turbines, stationary combustion furnaces, whatever, if you go to oxy-combustion of hydrogen, you don't have problem of nitrogen oxides. So also there, in stationary application, direct use of oxygen. So what you do, it's only you split by electricity the two molecules, and then you combine them back, and this is then quite efficient process. So also there, it's direct use besides the market that was addressed previously.
I would like to raise certain concerns. Maybe these are already well known, but I want to educate myself. Hydrogen, if you split water, that's very energy intensive. Methane reform is one of the best options, but there you also produce CO2. The second concern is hydrogen leakage is also something, the lightest element, so that also is quite possible, and it might lead to, particularly if it's related to IC technology, then there could be also possibilities of hazards. The third one is hydrogen embrittlement. you're always storing in tanks or even in the nozzles, or in those cases, formation of hydrides leading to embrittlement of metal is also possible. So these are the three concerns. Maybe it's already solved, but I wanted to just learn from you.
If I understood correctly, you compare the efficiency of the electrolyzers versus the efficiency of steam reforming natural gas. If we are talking about decarbonization, then steam reforming of natural gas is out of question. We should not be producing hydrogen from natural gas to replace natural gas. Efficiency is a very efficient process. Efficiency, theoretical efficiency is 100%, and you can have an electrolyzer that works at 95% efficiency, except it's going to be large. So the efficiency of electrolyzer is actually a function of the price. Right now, industrial electrolyzer is about 66 to 70% efficient, because that's the optimum point between capex and opex. Your second question was on hydrogen leakage and creating a greenhouse gas. Is that? Yes, that is an issue that is being investigated now. And the hydrogen embrittlement is a problem with only certain pipelines. Certain ductile pipes, steel pipes, are prone to embrittlement. But that can be solved with a liner inside the pipe, with a polyethylene or some other plastic a liner that prevents hydrogen going into the pipe. And not all the materials are prone to embrittlement. And that has been already taken care, and there's a whole industry that is making pipes for hydrogen that are not, that has this liner inside to prevent hydrogen going into the metal.
Maybe I agree with you. There are a lot of challenges still to be solved, so therefore it's not yet there in full extent. But I think also what is very important, as Professor Barbier said, is how to look in the future. I would say when I was in discussion at the site of European Green Vehicle Initiative, when they agreed on the next work program with European Commission, there were a lot of discussions how much we have raw materials, which are the technologies, and how it might not be possible to get to 250 due to several constraints. And then a man from a commission said very wise things. So you cannot look in 2050 with the technology of 2020. So we will put a lot of investigations in, we will put a lot of money in, and in 30 years or in 20 years, there will be a lot of progress. So I would say, I agree, there are currently quite some, let's say, challenges. I would by far not dare to say there are obstacles, but I think with future further developments, many of them will be resolved, but also maybe there will be some slightly different pathways that we can imagine them now, because the technology will lead us in this direction. So I think we should really be open in that kind and not be blocking the things. So, but yes, certainly there is a lot to solve still.
Other questions? If there are any. There on the back.
Safety-related question. Hydrogen car in garage with leakage of hydrogen. How dangerous it is?
Okay. Hydrogen leaks in a closed space, such as a garage, can be an issue. Hydrogen behaves very similar to natural gas. So hydrogen is lighter than air. It doesn't create a layer at the bottom. Hydrogen goes up. And the studies that have been done so far, both modeling and experimental studies, have shown that in any space that has any kind of ventilation, including even natural ventilation, it is practically impossible to create a flammable mixture of hydrogen and air. Hydrogen is flammable between 4 and 75%. You can create 4% of hydrogen, more than 4% of hydrogen concentration if there is a leak, and only about 30 centimeters above the leak, concentration will be more than 4%. Everything above that is be less. But if there is no ventilation, then yes, a cloud of hydrogen can form at the top, and then there must be a ventilation or a warning like we have now. CO in the garage is more than acceptable level, but I don't see that as a problem. There were a lot of studies also, hydrogen in the tunnels, and hydrogen in a closed space, but I don't see that as an obstacle.
Thank you, Frano. I just want to say that the comment of Professor Barbi was correct. So we have the experience of natural gas. For example, in Italy, we have a great number of cars running on natural gas. There are some limitations, obviously, in using natural gas, but these cars are running and are used. And again, probably hydrogen is a very good choice for energy-intensive transportation. Maybe for shorter distance, battery is an option. But again, battery, unfortunately, can be dangerous as well, and we had already some problems with the battery cars.
And I would also just add, if we imagine that there is a flammable concentration of hydrogen and that it caused explosion, the flame of hydrogen is going up. We didn't show, there is also video and a test on this issue, and if there is explosion, we will just see the flame going up, and it will go on in a few seconds, and your car will stay safe. So in comparison to today's commercial vehicles, you will have a burnt vehicle for combustion engine, and you will have your safe hydrogen vehicle. So it can happen, but it is so, I would not say impossible, but it is hard to get concentration, flammable concentration. Do you remember, Professor, the test of 2 cars in a 60 seconds?
Maybe if I might add, let's say, just on this, someone should also consider at which pressure level hydrogen leaks. Let's say if you're in the car and if you're at 700 bar, you have a highly supersonic flow. So, okay, it might cause combustible mixture, it might burn, but it will only cause flame. So it will not penetrate back in the tank. And when this will happen, tank is nearly empty, and due to these thick lines, you will be quite safe. So let's say this is some concern in some, let's say, crashes. But okay, where it might get dangerous is when there are really, when you, let's say if you're in defense application or military application, or if you're a severe crash where you will, let's say, smash the tank, where there will be some ignition point, then yes, a lot of hydrogen can burn at once. But otherwise, let's say if there is just penetration or leak at very high pressure, it burns, but there is very low probability of severe explosion.
Okay, there is another question there. Yeah, please.
Thank you. So we have a question from audience on YouTube. From the point of view of developing countries, which technology for hydrogen production is most suitable?
I would say it depends on the country, it depends on geographical position, but the recommendation is to use renewables to supply electricity and to produce hydrogen by water electrolysis wherever it's possible. So, but we are starting for renewables. I think this is a starting point for each country, and later see if it is electrolysis, if it is a waste, or some other technology.
Thank you. Okay, we do have time for very short take-home messages from our panelists. So please, Professor Barber.
For me, this is like a dream come true, what is happening now with hydrogen. I've been working for 30 years, and I have always been ahead of my time. I told people I work on science fiction. They would say, oh, you're a writer. No, I'm not. I'm creating the science fiction with hydrogen. But now hydrogen is not science fiction anymore. We talk about hydrogen in the forums like this and many other forums. We have now what this big project, North Adriatic Hydrogen Valley. We have many projects that are being intended in Croatia as well as in entire Europe. We have a budget of more than €1 billion in Europe for hydrogen projects. So this thing is happening. And I've been in my career through a lot of ups and downs, you know, of high expectations and then big disappointments. I think we are now at a very high level of high expectations from hydrogen. This is, I think, one of the last opportunities. If you don't use this opportunity, something else will take it.
Okay, I would say that there is no question if hydrogen will have a role in this energy transition and decarbonization process. It is just a question in which amount we will have hydrogen in a particular sector, because this energy transition, now it's obvious, will not work without hydrogen. Thank you.
Maybe since I started with digitalization, I will also end with it. I would say exactly as a follow-up of this is very important that, let's say, we really have very good virtual tools from designing renewable energy systems for correctly placing all energy vectors, so not imposing them by, let's say, some partial knowledge or even by some specific, let's say, stakeholders, but that things are really well calculated in advance and that we really then well plan. And let's say then it goes further down that we well design systems and then we well control and monitor systems, and then it goes in the feedback with all this knowledge. We then try to feed the planning tools. We will not solve all this also in North Adriatic Hydrogen Valley, but we have also a few tasks exactly on this, that in the region, Italy might be an exception, but let's say Croatia and Slovenia, we don't yet have large production facilities. But it's also very important that we don't just buy a electrolyzer and a fuel cell, but there are different electrolyzers, there are different fuel cells. They have to be properly integrated in the system. We should monitor them and then gain knowledge which products to buy, how to operate them, how to integrate them, and this significantly at the end influences the cost. Currently, people still think that there are these Lego blocks which are, let's say, fully compatible and that someone does not look into it. So I think this high-level knowledge will really need to have a lot of further digitalization, data processing, thinking, and this is also the knowledge that we have to develop in the region. And I think with all the synergies that North Adriatic Hydrogen Valley brings us, we will also there do a boost, not also between us who are from the academic community, but also to bring this knowledge to the industries which were not yet acquainted with the hydrogen.
Thank you. Yes, I want to start from what the other panelists said. First of all, for me too, is somehow an emotion to see that in Trieste we are installing in the next month one electrolyzer, one big electrolyzer, and it is, you know, it is something that sometimes I think, but is it true? Because it is more than, it is 30 years now that I'm working on hydrogen, but it is happening. But at the same time, we have to be realistic, and as Professor Katrasny said, hydrogen is only a part of this shift, of this energy shift. And even if this electrolyzer in Trieste and the other in Croatia and in Slovenia that will be installed, in Trieste, for example, we will produce 400 tons of hydrogen per year. So it is true that the energy content of hydrogen is 3 times more or less natural gas or oil. So it means that it is about 1,000 tons per year of hydrogen. A ship in one day consumes 25, 30 tons. So you see that it is nothing. But it is a starting point. Hydrogen will not solve all the problems. We have to focus on fundamental research on renewable energy. There is quite a lot of a way to improve and to increase the efficiency of the overall system. And still, hydrogen is very expensive. And again, energy planning, as Professor Katrasnik said, it is very important. We cannot, let's say, waste energy because we don't use it the right way. We have to plan in advance and how to use this energy, and not only at the design point, not just that we have a plant, we need 500 tons per day and so on. No, we have to plan at part load operation in all and the cross-sector integration is very important. So transportation, hard to abate sector, it is important. We have to plan, and digitalization for this aim is, I'll say, essential. Thank you.
Thank you once again for a very nice presentation and discussion. So we are about to end this session on hydrogen, and I think there is a message of President, or should I just invite you to the lunch, which is already served, I think so, in the lobby in the front of the lecture room.
And that is why I'm here, because I just wanted to say that it's time for the lunch break now, of course, 1 hour, but when you exit the room and find no food, please don't be alarmed, because for diversity reasons, we have decided to move it to the hotel restaurant, which is to the right and then to the right.
Okay, thank you.
Evo ga, tu će. Da. Samo ta glava. Hvala lijepa.
Eventualno, znači ako hoćemo pozoriti ali ti staviti ništa nećemo dirati jer nije bila u stanju da zapamti informaciju da mora doći do birane porekne. Prema tome naprosto ostaviti nam vremena. Jeste vi?
Test, test, test. Jedan, dva, jedan, dva. Test, test, test. Test, test, test. 1, 2, 1, 2. Test, test, test.
se da ga ipak možda isključim, da ne bude mikrofonije.
Uključeno je.
Ja mislim da ne bude mikrofonije sad već.
Pa ne. 1, 2. Stišamo mi. Dobro.
I think that we are ready to continue our conference. Ladies and gentlemen, dear colleagues, welcome to the session Mobility Model Shift. My name is Hrvoje Gold, and I'm a retired professor of Informatics and Intelligent Transportation System at the Faculty of Transport and Traffic Sciences, University of Zagreb. I have honor to moderate this session, and at the beginning I will say a few facts about the main theme of this session. The 2030 Agenda for Sustainable Development of United Nations and its Sustainable Development Goals fully reflect the important supporting role of transport in achieving global sustainable development. Building sustainable transport system that is safe, convenient, efficient, green, economical, inclusive, and resilient is a major move towards high-quality economic and social developments. Comfort, practicality, speed, individual freedom, flexibility, and social status are well-known attractive factors of private cars. But today, we are facing a huge burden of negative side effects of using private cars. Private cars are a major polluter in the transport system. Thus, there is a time for concrete measures to build a better future. I have the honor to announce our invited speaker, Professor Borna Abramovic, who will give the introductory talk. Borna is a professor and head of chair for railway transport management at the Faculty of Transport and Traffic Sciences at the University of Zagreb. His area of interest are railway transport, integrated passenger transport systems, transport forecast, transport demand, and game theory. Well, Borna, please take the floor.
Thank you, Professor Gold. Hello, everyone. So today I have quite a challenging task. So I have last session, and I have session after the lunch. So I hope so that you will not go to sleep. Like Professor Gold said, my name is Borna Abramovic. I am coming from University of Zagreb, Faculty of Transport and Traffic Sciences, and also I am member of Croatian Academy of Engineers, Department of Transport. So for today invited lecture, I make a short content. So the first part of the lecture will be introduction. The second part, we will talk about European Green Deal. Then we will talk about some interesting statistics. Then we will talk about car. The car is mighty or almighty. Then we will ask ourselves, can we change this paradigm that car is mighty? And I will not have classical conclusion, rather something instead of the conclusion. So we can start. For introduction, I prepare some interesting words. So for example, green policy. Is here anyone that do not heard about green policy? You are all familiar with this word, green policy. Then the second word is decarbonization. Also, everyone know this word? Yes, excellent. The third word is digitalization. Very modern word. Okay, digital. Everything is digital. The fourth word is resistance. So, how resist we are, for example, when we look back at the COVID. And the last but not the least, sustainability. All these words are so-called buzzwords. I think that each of us has our own definition what mean each of these words. And we can debate, I think, for a few days what of this each word significant to each of us. At the end of the day, we need to make some compromise and go in the right direction. So, at the European level, European Union level, they make so-called a European Green Deal. The idea of European Union plan is turning to the best climate neutral continent. So it's very advanced thought. So that the Europe will be the first climate neutral continent. So what is idea behind the European Green Deal? It will be transform European Union into modern, resource efficient, and competitive economy. This is also three buzzwords. Okay, modern, we are all modern. You know, we are here, so we need to be modern. Resource efficient, so more for less or less for more. We can debate about that. And competitive. So this is very important. We need to be competitive. So what the European Green Deal says, no net emission from greenhouse gases by 2050. So this is like the first major goal. So it's quite near. So maybe in 25 years, we need to achieve this goal. It is possible? We shall see. Probably not. But we can strive to do it. The second thing is economic growth decoupled from resource use. So how we can have economic growth that we don't use so much resources. So when we speak with economics, they will tell you that this is a little bit crazy. Okay, so you need to have resources to make something. So this is like a very philosophical question, how we can do economic growth that we decoupled from the resource use. And the third, and very important for all of us, that no person and no place left behind. So it's mean that this European Green Deal will deal with all people, not only in urban area, not only in the richest country, but also in rural area and in poorest country of the Europe. So this is very important because this last goal has like this social influence. So everyone is invited to do something about European Green Deal. And of course, when we talk about strategies, when we talk about plans, I think the very important issue is there money? Who will pay for that? Okay, so we're living in capitalism, so everything you need to pay. And the question is how much money we have for these goals. So when you read the official documents of European Union, they will start you like this. 1/3 of 1.8 trillion euros will be invested to European Green Deal. This is very marketing approach. You know, 1/3 of 1.8 million. We are here all engineers, so for us 1/3 it's not so problematic, okay? But imagine for people, they will hear only 1.8 million. They will not hear 1/3. It's complicated, okay? But 1/3, it's 0.6. So it's not so much money, okay? So they said that they will investment for this new program called Next Generation EU for 7-year budget planning. So from this year to 2030, and we will spend 0.6 trillion euros for achieving these 3 goals that I present you in a slide. So what are the benefits of European Green Deal? There is a list of the benefits. So we start with the first topic, fresh air, clean water, healthy soil, and biodiversity. This is very important for all of us, not only for transport sector. Renovated energy efficient buildings. This is very hot topic. How much energy buildings need to keep it running? Third things, healthy and affordable food. You can see now in last maybe 6 months, the food is quite expensive. So the prices of the food is rising quite high. Third, very important for transport session, more public transport. I will tackle this issue later, but this is very important when we talk about European Green Deal, that we need more public transport. The next one is cleaner energy and cutting edge clean technological innovation. So we need to think about it, how to produce clean energy, how we can use some energy to be clean. So it's not so easy task. The second thing, it's longer lasting products that can be repaired, recycled, and reused. This is very hot topic at the Brussels level. So you know that some companies has so-called like memory effect in their equipment. So after 3, 5, or 6, 7 years, the equipment broke down, but not because the equipment is bad or something go wrong, but it's like life cycle of this equipment. So the European Union want that we have lasting product that can be repaired. Next thing is future-proof jobs and skills training for the transition. This is very important. For example, I am coming from University of Zagreb, and it's a very reasonable question. What we are teaching our students today that can be done in 5 years period for now. So we are learning them new technology, or we are recycling some old PowerPoint slides. So for people that are working at university level, it's very important that they introduce new topics, new things, new idea in current curriculum to prepare students for the new challenges in the future. And last but not the least, global competitive and resistant industry. So we know that Europe is one of the continents, very old continent, we can say like old lady, and we need to produce more competitive and resistant industry. Okay, so the next topic, like I said, will be some interesting statistics. I like to say that behind every number there is a story. So each of slide with a statistic, you can speak maybe one day, half a day, depending on how much numbers you have on the slide. So I will start with the first slide. It's final energy consumption in EU 27 by sectors. So on the left side, so here, you can see very interesting graph that follow from 1990s to 2021 energy consumption of different sectors. The sectors, according to statistics, are industry, transport, household and services, and agriculture. And what we can see on this slide, we can see that European industry is dropping down by consumption of energy. We can make two conclusions. The first conclusion, we don't have any more industry. And the second conclusion, the industry is much more efficient. Probably the truth is somewhere in the middle. Okay. And then what we can see here in transport industry, we can see that the transport industry use more and more energy. So it means that we have more and more transport on roads, railway, inland waterways, maritime transport, and so on. And then we can see the household and agriculture is almost stable. So there is no big fluctuation in these two sectors. And when we look at the last year, 2021, we can see that the transport has 29.2% of whole energy consumption at EU level. That is huge amount of energy consumption. Okay, imagine that the whole household, so all the people spending 42% and the transport almost 30%. So this is critical. Okay, we consume quite a lot energy in transport sector. Okay, the next graph. Greenhouse gas emissions by the sector. So, according to statistics, there is some different sectors. So, the first sector is energy industry. The second one is manufacturing and construction. The third one is transport. The fourth one is industrial processes and product use. The next one is agriculture, and then the waste. And then there is other. So, it means by the percent, it's not so high when you look at each of the sector inside of the other. So I combine all the others together. So what we can see here, we can see that transport has 24.1% of all greenhouse gas emission in European Union. And when we look at other things, for example, energy industry has the less. So this is also interesting. Okay, so they produce the energy, and they don't produce so much emissions. Okay, so we need to ask ourselves where the transport is going. So where we are going with the transport, because again, this number is quite high. Okay, the next one is the same topic, but dividing by the modes. So what modes we have? We have civil aviation, road transport, railways, navigation. It means that it's maritime transport and inland waterways. Okay, together we call that navigation, and then all others modes of transport. here, it's very interesting fact, when you look at carefully, that the road has the highest amount. This we all know, of course. The road, there are combustion engines, so it's very like natural story that we have some issue with the road. So then we have navigation, and then we have civil aviation. So it's interesting that railway it's very low on this scale when we look greenhouse emissions by the modes. Okay, next slide, it's about CO2 emissions by the sector. This is the same sector like with greenhouse gas emissions. And we can see here, for example, the transport, it's almost the same percentage, so 29.2%. Again, you can see when you look at others sectors that the most producer of CO2 emission at European level, it's again transport. Okay, so we are doing something wrong, so it's not good. When we look carefully by the modes, again, the same 5 modes like previous slides, we can see again that we have some problems or challenges with the road transport. So the majority of CO2 emission, 2/3, it's coming from CO2 emissions. And then we have so-called land-based passenger transport in European Union. So on this graph, I also took statistics from 2000 to 2020, and look what is the modal share of land use transport. And what we can see here, that the road transport is always growing a little bit. Okay, and other transport are shrinking or stay stable. What that means? It means that each of the strategy that we produce in last 30 years was not good. So in each strategy, we tell that we will use more railway, we will use more inner waterways, we will use less roads. But when you look at the statistics, this is all wrong. So all strategy that we write in last 30 years are like very bad strategies. So there was quite huge amount of the papers, huge amount of ideas, but behind these ideas there is no some concrete goals, what we can do to improve overall modal split of land use transport in Europe. So with this slide I will conclude this statistical part so that we have something to talk about in our panel, and I will start with the new part of presentation. This is the car is mighty. So for me the first question is, can we live without a car? So this is the question, and I can answer you immediately yes, and I know that 90% of you will say no. So I think it's possible, and for example, I don't have a car. No, my family have a car. So I travel whole world without a car. It's possible. Sometimes it's very challenging. We can say problematic also, okay, problematic. But I've done it, okay. For example, I travel with the train from Zagreb to Lisboa in Portugal. It's around 36 hours. I traveled from Zagreb to Kiev. It's also around 36 hours. Okay, I traveled from Zagreb to Stockholm. It's around 28 hours. So it's possible. It's not impossible. Okay. So the right question for all of us, how we can decrease usage of the car? This is, I think, the good question. But on other hands, we must be pragmatic. What is idea behind owning the private car? The first, when you ask people why you have a car, they will answer you comfort. I'm very comfortable. When I use the car, I'm excellent. I'm feeling super. So I'm alone in my car. Okay. The second thing, they said it's very practical. You know, I need to go to the shopping. And that's why I need a car, because I cannot go to the big shopping mall without the car. So for example, on my case, I don't have a car, so I don't go to the shopping malls. Okay. so bad for the economy, okay? But in the COVID, they invented home delivery. So I order my delivery at my home. So I don't go to the shopping, I only click on the internet, and they give me in 2 to 3 days at my doorsteps all things that I order. Okay, so it's car practical, probably yes, but it's necessary, probably no. The next thing is speed. People always said, I will be speedy when I have a car. Okay, and this speed, this is for me very questionable. For example, I will tell you a story in Germany. So I very often travel to Germany, and my regular travel line is between Munich and Berlin. So this is like the biggest and the third largest city in Germany. And with the train, you need 3 hours and 50 minutes. 3 hours, 50 minutes. It costs first class 69 euro. When you want to drive a car from Munich to Berlin, this is like minimum 6 hours when there is no congestion. You know, German word for congestion is Stau. So it's very famous word in Germany. So in ideal case, you will need 6 hours. So the speed is not the answer. Okay. The next thing, it's individual freedom. This is very important. This is very, very important. So people that use car always said, I have a freedom. I'm free man. How much you pay for your maintenance? Okay, so you are not free. Okay, and very important thing is flexibility. So cars are very flexible. So I can park anywhere, you know. I can come to this hotel and park in front of the hotel and enter the hotel. Not the truth. Okay, it's not possible. So flexibility, it's a little bit challenge also. It's their flexibility. And very, very important things that we engineers sometimes like do not look at very honestly is social status. Majority of people have a car because of the social status. Okay, this is very important. I have BMW, I have a Mercedes, I have Audi. So this is a social status. This is very important for the people, that they have social status. For example, my social status is I go with the tram. You know, it costs 2 million euro, one tram. So is that social status? Probably not, you know. So, and another thing that I do, I make one experiment. So on 26th of September 2023, I make a screenshot of Google Map, city of Zagreb. You can see here is the railway station. So our hotel is like, I think here somewhere. Okay. And when you look good at this map, it's like 11:30. Majority of roads are red. So it's congestion. It's off-peak hour in Zagreb. Off-peak hour, the roads are congested. So we can see that all of these ideas fell down with looking at one Google screenshot. Okay, so we need to think about it, where we are going. So when we talk about utilization of private car, what is interesting at European Union level? We have almost 250 million cars on the road. So this is huge number of the cars. Okay. Another thing, on average, EU cars are 12 years old. So it's quite old-fashioned cars. Okay, it's not so new cars. So the average of the cars in European Union is low. Interesting that battery electric and plug-in hybrid make only 1.5% of total EU car fleet. So we can say this is like statistical error. Okay, when you look at the whole picture, this is some kind of statistical error. Then motorization rates, it's huge. 567 cars per 1,000 people. This is huge. It means that each of us, second, when you look at left, has own car. You look at right, he has own car. Okay, so we are quite rich. And this is very interesting. On average, cars done only 12,000 kilometers per year. 12,000 kilometers. Imagine that 1 kilometer costs you €1. It means that you spend 12,000 euro per year only to drive the car with no gas, maintenance, and so on. So this is like pragmatic approach. And for me, that was very interesting fact that average distance in the cities around European Union, it's around 5 kilometers with the car. 5 kilometers, okay. When I was younger, I run. So for 5 kilometers, I need 70 minutes. Okay, now I'm a little bit older, so I need maybe 25 minutes. Okay, so but imagine you buy a car for 100,000 euro that you drove on average 5 kilometers. Okay, so are we ready for new normal? I like to make slides with cartoons of Andy Singer. Andy Singer is American. He lives in New Hampshire, so north part of the New York, on the north part, east part of America, northern part of New York, and he's quite activist against the car in America. Imagine he's an enemy of the government. Okay, he's the #1 when the government has issue with the car policy, and he has quite excellent cartoons. So he wrote these cartoons maybe 30 years ago, and he said, this is the myth, and this is the reality. And when we look at streets in every European city, exactly, this is the reality. This first graphic, we can see only in commercials. We cannot see this graphic in real life. Maybe on some very rural outskirt road somewhere in European Alps or something like that. Okay, and now the question is, can we change a paradigm? So let's either make a change. All changes are beginning with us, each of us. So when we want to change something, first we need to change ourselves, and then maybe we can ask others to change. So this is the most difficult part, you know, how to make change. So what is today's buzzword for changing our paradigm? It's mobility. You know this word, mobility. It's very modern. Everything is mobile, okay? Everything is mobility. So what means mobility? Mobility means moving. Every human has a force inside to move. We want to move, to go somewhere, to the toilet, to the kitchen, to the garden, to the school, to the work. So we are moving ourselves quite a lot. So what we must to move? We need to move people. Very often we move trains and buses. Okay, when you look at the public transport in your cities, you will see quite often empty trains and empty buses. This is wrong. We need to move people. The second thing, we need to move everywhere. Do not be concentrated only to urban areas. We need to move ourselves to the rural areas also. So we need to move everywhere where the people are living. The next thing, it's always. It's mean whole day services. When you have, for example, bus one time in the morning and one time in afternoon, it means that you don't have public transport. You have some bus that is scheduled 2 times per day. This is quite bad service. So we need to make always to run the services. And very important topic, it's building a sustainable system. So it's like philosophical, but what that mean? It means that we need to build a system for the people that moves, not vice versa. We don't need the system for the vehicles, for infrastructure, but we need system for the people. So how we can say what is tomorrow mobility? We can say that this is integrated public passenger transport system, and on this graph I try to catch all parts. So you see here all parts that we need to build to say to our people, to our citizens, that we are making better future for them. Okay, so for example, here we have car sharing, we have ride sharing, we have smart parking, we have commuting, we have some personal travel assistant tools, we have railway, we have buses, we have bicycles, we have connected vehicles, we have autonomous vehicles. So all of this micro solution need to be incorporated in one big system, and this one big system serve to the people. So this is like a puzzle, you know. This picture here, we can say it's a puzzle, and each of us is doing one puzzle. But when we combine all the puzzles together, we get the whole picture. We get the future mobility. And now another look, how the stakeholders see the story. Again, I have a cartoon from Andy Singer. So when we look at investments for roads, we say that this is a public investment. So it's very positive. It's huge positive. But when we see building a new tram, railway line, light rail system, metro, or something like that, usually people say wasteful subsidies. Okay, so we are now like on the border. What do we want to change? We want to change the titles of these two graphics. So this is wasteful subsidies, and this is public investment. It will need time. Probably I will go to the pension, and people still will talk about this issue. Okay, so it's not so modern issue. And instead of the conclusion, I like to quote one American guy, Anthony Fox. He said following things: the reality about transportation is the future oriented. If we're planning for what we have, we are behind the curve. What he wants to say to us: when we reuse current models, current opinion, current knowledge, we are late. Okay, we need to think at least 5 to 10 years in front of us to see what can happen and what we can do that this is possible. Nowadays we are here in Zagreb, capital of Croatia, and this hotel, it's quite new. It's only 25 years old hotel, but it's in neighborhood that it's built in the beginning of the 20th century. And you can look the roads around this hotel. Imagine 120 years ago, size of the roads that they built here. They was a visionaries. Okay, imagine in that period of time, there was no cars in Zagreb. Okay, zero. But they built quite nice roads. So that is a vision. We need to see what can happen in the future to make future possible. We need to invent the future. Future will come always, but it's maybe better that we invented the future. So, thank you for your attention.
Thank you, Borna. Now I will invite our panelists to take their positions. And we don't have here the presentation, but I hope that our panels will be very interesting in their comments and discussions. So I'd like at first to introduce all of them, and then we start the discussion. Well, I will start with the ladies. Professor Edna Mrnjavac is a full professor at the Faculty of Tourism and Hospitality Management in Opatija. That's near the University of Rijeka, that's on the coast. Her research interests include traffic in tourism, traffic management in tourism destinations, and supply chain management in tourism, with particular emphasis on sustainability and mobility of traffic and tourism. Croatia is a touristic land, and we are very interested to realize the transport system which is acceptable, and all these facts that Borna said about, especially for the strangers to come to this beautiful land. Professor Elmar Fürst, he's associate professor at the Institute for Transport and Logistics Management at Vienna University, Austria. He has been involved in various international and national projects on sustainability in the domain of transport, and particularly in accessible mobility and transport. Furthermore, he is the chairman of the Hilfsgemeinschaft, the Austrian association supporting the blind and visually impaired, and chairman and member of number of scientific and standardization committees. Professor Adam Török is a full professor at the Budapest University of Technology and Economics. He holds Master of Science in Transport Engineering and Financing Engineering and PhD in Transport Sciences and Business and Management. He earned the Doctorate of Hungarian Academy of Sciences. He is an active, Doctor of Hungarian Academy of Sciences. He is an active member of the Transport Scientific Association and Hungarian Logistic Association. Professor Marko Ševrović is Associate Professor at the Faculty of Transport Traffic Sciences, University of Zagreb, where he holds the position of Head Department for Transport Planning. He has more than 20 years of experience working on different transport planning, road infrastructure design, and road safety, EuroRAP, IRAP projects in Croatia and abroad. As well, he participates in EU-funded projects related to road infrastructure safety, currently Horizon Project, FEBE, and Elaborator. Well, that's... Okay, now we are ready for discussion. Well, I think that Borna's presentation were a little bit maybe controversial for someone, but it's very inspirative and challenging. So I think at first that each of you make a little comment about Borna's thinking and his expression of freedom of be by themselves. So where we start, maybe Elmar, you can try it, please.
Yeah, thanks so much. I'm very glad to be here and to have the opportunity to discuss with you and to be invited to this distinguished event. Bona, I listened to your discussion with your friends, and so I thought it would be fine, just for the sake of the discussion, to take a little bit a controversial point of view, but at the end, eventually, we will see that we maybe come to the same conclusions, yeah? So maybe this is interesting. I thought, because I've noticed during the last maybe years that I don't say that you do this, but I think that in many disciplines of science, discussion has become rather ideologic instead of controversial and fruitful. And I think that is something we should avoid, and that is why I'm very happy to be able to speak openly here and just for fun take the opposite role, so to say, a little bit. You said we have huge amounts of transport. Yes, that is true, but I say we need some transport. We can have some reductions, that's clear, and we should omit some transports which are useless or which are not necessary or which are not efficient. But on the other hand, if we had no transport at all, we have a specialized economy and globalized economy, we wanted to have this. We joined the EU to have free flows of goods and people and so on. So the freedom was a very big thing, and also the big markets, the integrated markets. So this must have had a value for those people who decided that we should have a union and not segregated countries, which, so to say, work on a standalone basis. Yeah, and so what is the right amount of transport? That is, of course, what we have to find out, because if there is no transport at all, everyone could sit on his own tree, maybe, if there are enough trees. That is a question. We should plant more trees, that is for sure, because then also the emissions would be, so we would have more oxygen instead of CO2. It would be a good idea to plant more trees, so that is something we can at the moment agree upon. I was in Poland some weeks ago at the Eurotrans conference, and I heard somebody say, I do not say who it was, yeah, because he said the European Green Deal is something like a declaration of war against the competitiveness of Europe. And we should also take care about these opinions, take this into consideration, because what does it mean if we restrict ourselves, that we don't want to produce any more combustion engines and so on, and that we force people to drive electric cars, that this can be, of course, a productivity disadvantage against other parts of the world, and we should have this in mind. And I always take care when somebody says something has no alternatives. I think we always have alternatives, and at any point in time. So it's definite. I was always a person who was against environmental friendliness to avoid waste and so on. I never understand why people can put their waste in the forest, or why we have to pollute so much for useless things and so on. But we have filters, we have maybe technologies, we have advancements in that respect, so that we can restrict ourselves, and I'm sure in some respect we should also do that. But it's always the question, what is the right amount? Can we live without a car? Yes, of course we can, but is it necessary to do it? And I think that the car has some alternatives, as well as the lorry for freight transport. There must be a reason why all the shipments go by on the road and not by on the train. Yeah. Why does the road has so huge amounts of parts and volumes, transport volumes? Why is that the case? Obviously, it's maybe cheaper, it's more efficient, it's faster, whatever. Yeah, nobody hinders the rail companies to be to offer something better. Yeah. I made a study. I was working for Statistics Austria some years ago, and I found out that 80%. This is true for Austrian statistics some years ago, but I still believe that this hasn't changed hugely. At that time, some years ago, 80% of the transport volume transported on the road was transported for less than 80 kilometers. So I don't think that we have a big chance to shift this on rail, but what we have a chance to make lorries environmental friendly, and we have a chance to have better fuels available to reduce emissions, and maybe to have better technologies in this respect. I think there is this freedom of choice. You have mentioned that, and I think this is very important. But the actual choice is a function of what is offered. And if the public transport offered is for instance, has high service levels, and if it's excellent and also it's reliable, and I also came here by train, of course, yeah, because could have taken the car also, but I thought that the train is better and so forth. But I had 2 interruptions which were unforeseeable, and I had the fear that I won't get my connection in Villach, and if I had missed that, I would not be here. Yeah? So that is the problem. Yeah? And for instance, if we look at the German railways at the moment, which is a catastrophe, they don't have the infrastructure, they lag behind. And even if they invest millions and billions of euros, it will take some time. So I think the mixture will be the outcome, and that is maybe then what we can agree upon. I think that the future mobility will pretty much look like what you presented on your last slide. Yeah. So I believe this too. And I think that, for instance, electric mobility will be a part of it, but it will not solve the entire problem. There are the questions, where do we get the resources from? Don't raise the point where and by whom the rare earths are extracted. We have all these things, and the problems of safety when for instance, we had this dreadful bus accident in Venice, and at the moment the thing started to burn. Yeah, this would maybe not have happened if this was a diesel bus. Maybe, I don't know. I'm not an expert here. Better experts in the room probably, but I think we have to really take this into consideration, and also the fear about this. And there is another alternative. You mentioned it as well. This is walking and cycling, and I'm pretty much in favor of that. But not everybody can walk and cycle. So there are, and that is my other, so to say, if I put on my other hat, as representative of people with disabilities. Many people with disabilities, they cannot do this, but if we have consider, for instance, shared spaces or something, and there's really a question of culture, I think. If we look to Holland or to Denmark, there is a better cycling culture, like for instance in Austria. If you go through the Marie-Hilfer-Straße, which is a big shopping street in Vienna, and a shared space, then you can fear of your life, yeah, because the cyclists, some drive by 10 centimeters before your nose, yeah, and that is very, very dangerous. So we need to also have a cultural shift in this respect. But in the end, I believe that we will, in fact, have, and so that is the consensus I would like to end with. We will have some sort of integrated transport system, like it was presented. I would have pretty much made the same slide. So that is a good point for the end. Thank you very much.
I come from Faculty of Tourism and Hospitality Management at the University of Rijeka, but I'm of course a traffic engineer, so my field of interest is a concept of traffic and tourism. I agree with the majority of Borna's ideas and arguments. And I will say once more what Borna pointed out, that mobility is about people. So we have had huge strategies looking in the future and so on, but always related to infrastructure, building huge investments, and so on and so on. And many times we just left some older infrastructure somewhere behind where the new infrastructure was built. So one of the many an important element of mobility and mobility concept is to use the existing infrastructure as much as possible. This is very important from the tourism point of view, because we know that all over the Europe, some old railways, which Borna and I like so very, very much, because I also like railways very much. So, for example, there is a huge potential still in European Union, but also, of course, in Croatia. For example, to use all the railways, to use some other infrastructure as also as a tourism attraction. I have read several years ago, I don't remember now the document which was made by some of the part of the European Union, which said that the main role of traffic is to secure higher quality of life of all inhabitants of European Union. Borna said it means people living in urban areas, but also people living in rural areas. I would like to add that traffic is also very important for all tourism destinations because it enables visitors and tourists to enjoy all the elements, all the services, all the offer that a destination is able to supply, to offer to the visitors. So, generally speaking, about the role of traffic and, of course, of mobility in tourism, we know that there are some fields of connection. It is, at the first place, how emittive market, the places where tourists live, is connected to the destination. So the connection, traffic connection between emittive market and the destination. Then it is a question of how traffic is organized on the field of destination. This is very important because when organizing mobility in the field of tourism destination, we have always to bear in mind how tourists arrive from their homes, from the surrounding countries to the very tourism destination. And then there's also traffic which acts as an attraction in the tourism destination. There is a question of supply, how to supply a tourism destination, and so on and so on. Referring to the figures that Borna pointed out, I will add just little something about the relationship between traffic and tourism. So when looking at the tourism flows in European Union, the majority is performed by road traffic. So 49% is performed by road traffic, 43% of which by personal cars. So it's something that is very, very similar or just on the same line as your general data, Borna. So going on, plane 41%, train 5%, ship 3%. As we are, of course, interested in our situation in Croatia, we have even worse modal split because 79% of tourists arriving to our country uses road traffic, 60% of which personal car. So if we just bear in mind the data from earlier, we know that we have a big problem in our tourism and in relationship between traffic and tourism. Then plane 20%, ship 1%. I'm so very sorry for you, Borna, and for me, but official statistic is not speaking about any railway traffic and tourists coming from some other countries to Croatia, although we know that some tourists from Czech Republic and also I hope from some other European countries also come to Croatia by railways. So I will just get some other remarks, then maybe later on we can discuss something. In our tourism destinations, all the research that is done about traffic situation, satisfaction of tourists coming to our destinations, and so on and so on, as well as what local authority and tourism stakeholders think about the relationship between tourists and traffic. They all speak about lack of parking places. And I will put a question. Is there really a possibility to produce such amount of parking places if 80% of tourists, thinking about Croatia, come by road and the majority of them use personal cars? So it is, of course, not possible. There is another problem which I think that we do not understand to the full extent when we speak about the relationship between tourism and traffic, and that is the fact that all those tourists that come to European Union by plane, by ship, and by railways, in the end, when they come to the destination, they mainly use a car. So just to finish this my short introduction, yes, I agree with you, Borna, that mobility concept is a puzzle. So the only solution is a puzzle of many elements, of many different kinds of traffic solutions, green solutions, smart solutions. As my colleague previously said, we have never to forget pedestrian traffic, cycling traffic, which is very important from the health point of view, usage of space, because when we speak about the mobility concept, it is not only a question of how transport is polluting the environment, it is also a huge eater of space everywhere, and that is something that we have bear in mind. So it is important to think always, as I mentioned, about the pedestrian traffic, cycling traffic, because it is good from many aspects. And I should say that people generally are aware about the problem with environment pollution, sustainability, and so on. And at the end, I think that they are willing to some extent to change their habits. I don't agree with you, Borna, that it is possible to live without a car. Looking from the point of view of tourists, I think that we really have to make a huge effort to put on a table all the possible solutions, create that puzzle we have spoken earlier, and to enable to limit the usage of car as much as possible. So it's a question of a source of energy use in the car and so on, but for the moment, I think it is enough for the introduction. Thank you.
Good afternoon. Thank you very much. First of all, I would like to thank for the organizers to invite me here as a panelist. And then thank you very much, Professor Gold, for the introduction, and congratulations, Borna, for the presentation. First of all, I would like to come back to your very last slide. I think that, as you mentioned, in Zagreb 100 years ago, when they designed these magnificent streets, they were very much lucky. They could have very good views in the future. Meanwhile, there were decades where nothing has changed. Meanwhile, nowadays we have a very rapidly changing economic environment, a lot of new inventions, and I don't know anyone who would be able to foresee what is in the future in 5 or 10 years period. Meanwhile, if you consider that 150 years ago, 200 years ago, there were people who could imagine a couple of decades or 100 years in the future. So it's a very tough problem. If you would consider how the texture of a city can change with the autonomous mobility or with the other type of micromobility usage, then it's very hard to make a long-term forecast on demand. On the other hand, I would also draw your attention and come back with the previous panelists that in terms of mobility, I don't think that the mobility or transportation itself can be neglected, because if we consider that the raw materials or the people in space as inequally distributed, that means that somehow if we would like to produce something or consume some goods or services, then we have to have transportation until somebody invites teleportation for sure. And the third thing that I would like to add to your presentation, that if we're starting to consider that in these, I would say, trips, somehow we would be able to neglect or even discuss or reveal the social revenue and the social cost of one trip, and also considering the private revenue and private cost, then in one trip you would have the, I would say, we could measure the, if it have a social benefit or a private benefit of one trip. And in case we have a social benefit and a private benefit, then it can be supported, the trip, by the society. If the trip would have, I would say, only private benefit, but it's not gaining any revenue for the society, then it should be somehow penalized, for example, with taxation or pricing regimes, or technological, or changing the legal background. And of course, we can say with the same, if we have, unfortunately, private cost or social cost in some trips, that is also could be a huge problem. So on the other hand, we also need to say that what you mentioned, and I'm very good that you have showed us these figures in statistics, that unfortunately nowadays in Europe, the internal combustion engines are very dominating. That means that we are burning fossil fuels, and from my point of view, technological point of view, that at the moment we don't have alternative solutions that could change this huge amount of number of vehicles in a very short term. Of course, if you see the researches nowadays, then there is hydrogen or electricity, but there is a lot of questions that arises. Who is going to produce the electricity? Who is going to produce the battery? Is it going to be green hydrogen? So a lot of, and what is, at the moment we can say that the power density is still the largest of the fossil fuels, so are very questioning of these technologies in the current format nowadays. And again, would come back that I don't know what is going to be in the next 50, 25 or 30 years. It's a huge question to elaborate. Thank you.
Thank you so much. Last, I hope not least, for the opening. Yeah, since my background is purely transport and transport planning, and I've been working in this field for basically whole of my professional career with links to road safety. I want to maybe come back to some of the basics that Borna raised in the equation, and that's mobility. And I always, first thing I talk to my students is, why do we have mobility? Big question. Why do we have transport? Why do we have traffic? And if you think about it in depth, you actually can come to 5 reasons why people travel. It's either work, it's either free time, it's education, health, and what's the 5th? What do you think? Shopping. These are 5 main things that people travel. Yes, we need mobility to get our needs in these all 5 fields. If we can meet those needs, we are free. So that's the key. My answer would be, if you live in London, if you live in Brussels, if you live in Amsterdam, if you live in Copenhagen, it's absolutely okay to live without a car, and you can live without a car. But if you live in Rijeka, if you live in Opatija, or if you live on an island in Croatia, it's impossible. You can't have all of those 5 needs met without a car. And that's the key problem. Also, one other aspect, which I always, I've been writing down some of those strategies that Borna was saying, especially regarding the road safety, but also the transport planning strategies, SUMPs, sustainable urban mobility plans, as you know them. And I always ask myself the question, what would make me change the way I do my travels? So if I travel from my home to my university, which is a 5-kilometer trip, with my car that I own, and I do around 40 to 50,000 kilometers a year, and I do for work only 5% of this. So the cost of owning a car is not because of the work, it's because of everything else. And if it takes me 17 minutes in a rush hour in Zagreb to get from my door to my door at the university, and it takes me 45 minutes with the fastest public transport option, public transport is not an option for me. Because it takes up almost 1 hour a day of my time. And my most precious value that I currently have, besides my health, is my time. And if, on the other hand, public transport was as good that it took a little bit longer, but I could, for example, do my emails in the tram, which I can't in Zagreb, because the public transport is packed, it's hot, it's cold, it's windy, it's not on time. There is no option that it can make me move and change my mode. On the other hand, what if somebody says you cannot park your car anywhere near the university, and you would have to walk, or I have to pay 100 euros per day? Let's say I'm now being unrealistic, but these are the options that we have. You know, the cost function. The cost function is what we all calculate in the back of our heads. Nobody thinks about it, but as humans, we calculate it. As transport engineers, we have to understand it. I am having this cost function in my head. In road safety, we call it the willingness to pay. How much you are willing to pay to save your life. If I give you an option to travel from point A to B with a ticket that is a plane ticket that is 500 euros cheaper, but it flies across Ukraine, would you take this one? But if it's 5,000 euros cheaper, if it's 10,000 euros cheaper, that's the willingness to pay. Would you, if you have a gas heater at home, how much would you pay for a device that would alert you if there is a CO concentration that is too high? In a low-income country, nobody has it. In a high-income country, everybody has it, because the change of the willingness to pay. It's the same with the time. If I'm a university professor, I'm willing to pay more for my time. If I am a student, I'm willing to pay less. And this is the cost function that we are all calculating in our head. So I would say, basically, the answer is quite simple. If you want to change the mode of transport, think about the cost function and how you can interfere it. And there is always, like in economy, I guess people who are economists can say about it, it's supply and demand. There are always two sides that you can change. Thanks.
Thank you for your answers, or your comments, better to say. Maybe some conclusion that we cannot be with the car for a longer time, I think. But maybe there is a change of behavior. As someone here in some former presentation said, and I heard that maybe 20 years ago in one conference when it was also mentioned in some slides, the Mercedes, they made the plans about the cars in the future, and they said that the younger people don't want to have the ownership. They don't want to be responsive. So it's easier for them, especially now when the technology give the opportunity to do that, just to share the car. And I don't know, maybe this one, there will be less cars, of course, because we can share it. And maybe this is one of shift. I don't know. Maybe naive thinking. Okay. Now, maybe the thing that Borna mentioned and we don't discuss here is this integrated transport. We said that the cars are mostly involved in all this transportation system, but what you can say about the integrated transport, maybe, Borna? You are.
Okay, thank you for your question. So when we speak about integrated public transport system, this is like very old idea, you know. It was invented in Germany, of course, you know, they are a technical nation. So in '96 in Hamburg, they invented integrated public transport system. What was the problem these days in Hamburg? They have different operators of tram line, railway line, light rail line, buses, and some ships also. You know that the Hamburg is a harbor. And it was very complicated to use the system. And one guy, very smart engineer, said, okay, we will make integration of all modes transport. And we need to do three things. Always we need to do three things. The first thing is that we have one timetable. So the persons that want to use the system need to look origin point and destination point. And they can travel quite easy with one timetable through the system. The second thing, for people, very important thing, that they use only one ticket. So when I enter origin station, I don't need to think about the tariff policy of each of the company. So I only need to know how much I need to pay from A to B, so origin to destination. And the third thing that it's very, very important, especially in today's life, it's information. Passenger need to have information on time. So pre-trip, during the trip, and after the trip. So this is like three pillars for good integrated public transport system. So we need to have one timetable, one ticket, and one information system. So I think technically looking, today this is very simple. Okay, so where is the problem? The problem is, are we ready on all levels to introduce this kind of a system? In west part of the Europe, for example, Germany, Netherlands, France, Switzerland, this is like a completely normal system. They don't debate about that. For them, it's like a normal, okay. In east part of the Europe, this is very questionable system. So depending of the states or depending of the area, some area has quite excellent system, for example, the Czech Republic, and some area do not have any kind of a system, for example, Croatia. So what is the point of integrated passenger public transport system? The point is that we make public transport easier for our users. So like Marco said, there is some cost to pay. And people always think how much I need to pay. Okay, always in the mind we think about the prices. So when I can pay less and maybe travel a little bit more, for me this can be a solution. So sometimes we need to discuss. And I agree that when you have excellent integrated public passenger system, for example, nowadays, last 5 years, the first city in Europe that won like a prize for best this kind of system, it's Vienna. So in Vienna, it's very easy that you use public transport system. You don't need to know language. It's very simple, you know, and you can travel through the whole Vienna for very cheap amount of the money. Okay, so you pay €1 per day. Imagine the whole system in city, every type of the modes, you pay only €1 per day. So it's possible. Okay, Vienna make it possible. But of course, why they make it possible? Because they have some measures to make some other parts of the cost very expensive. For example, Professor Edna and Marco said parking. So the parking is in Vienna, it's very expensive. You need to be quite a rich guy to park your car in Vienna. So it's always balancing what we want to achieve and how we want to achieve. And always we need to keep in mind that we are doing that for the people, because when the people are not satisfied with this kind of the system, they will not use the system. So we always need to have a system that has reasonable satisfaction for the users, that they will use in everyday situation this kind of the system.
Thank you. May I ask, Professor, first, also for the people with reduced mobility, how it looks to use this integrated transport? Because Borna mentioned Vienna, and you come from Vienna. So just to give the comment about that, and in general, especially maybe with these electric cars, and so, which is not so, you cannot hear it if you are right, but if you have some problems, there is difficult to hear. Maybe from this aspect to say about these things. Thank you.
First of all, in general, yes, Vienna has a good public transport system, but it depends always on the relation. When it's I have the same problem when I go from my home to the city center, I would never have the idea to take a car, because it's much faster to take the underground. It's cheaper, also because of the parking, and I would probably not find a parking space in the city center. But for instance, when I was a student, when I had to go from my former home with my parents to the university, it was 7 minutes about by car, and at least 45 minutes by public transport. So I was very happy, because I have a vision impairment, so I cannot drive on my own, but I was very happy when somebody drove me for this 5 minutes. Yeah. Okay. Coming back to the point, of course, it was a political decision to have this 365 euro ticket. I still wondering, with all the inflation, how long they will maintain this price. Yeah. And the second thing they made, which was really almost a miracle, is this Klima ticket for all the entire area of Austria. So you have €1 for your province or your Bundesland. Yeah? You have €2 for your own province and the surrounding provinces, and €3 a day for the entire area of Austria. And that's of course very cheap, but it has some other effects, that people use public transport even if they wouldn't do it when it was costly. So they just decide on a Saturday, oh, it would be fine, let's go to Salzburg for a coffee. Yeah, this happens. And of course the price has no effect on the usage. So you could have cheaper tickets in peak hours, in off-peak hours than in peak hours. But this is gone, of course, mostly gone. Yeah, and so we have crowded trains sometimes, and some people have to leave the train in some situations. That is another problem, because again, that's a question, of course, of capacity as well. And coming back to persons with reduced mobility, many people with reduced mobility are forced to use public transport, and so they really rely on an accessible system. And Vienna has done, let's say, quite a good job. Yeah, together with the people of disability, the DPOs, disabled people organizations. There is an integrated planning group at the Austrian Disability Council with representatives of all different kinds of disabilities, starting from the sensual disabilities, vision impaired people, blind people, hard of hearing people, deaf people, going on to people with mental disabilities, physical disabilities, psychological disabilities, and so on. And so this group is there to do some counseling, of course, to if it is consulted in early stages of plannings, then it's a very good idea. For instance, Vienna Airport, that is always my benchmark example, because they opened a new terminal in 2013, and then they saw that it didn't work for most of the people because it was not accessible. Like they had a guiding system which was designed in a philosophical way, so that it's best integrated into the surroundings, so you could not see where an element of the guiding system was, yeah, because this was white and light gray, yeah, and so you could not see it, and this had to be completely changed. Then they took us for serious. They saw that the expertise which was given by the representatives of these people, who also have of course sometimes a professional background in the field, they are technicians, they are architects and so forth, and so they found out that asking the people about their opinion is a good thing, because of course they're not forced to do what they are saying, but if they do, in most cases they end up with a better result. And so what has to be understood, and maybe this is also important in this room or for this room, if a transport infrastructure, transport service or whatever is better accessible for somebody with a so-called reduced mobility, it is better accessible for everyone. And then this is also a step in the right direction of what we want to achieve, to get people to use public transport services.
Thank you. Marco, do you have any comments about this integrated system, transport system? Yes, please.
Always. Yeah. When we think about integrated transport, we think about, these trucks, trains, buses, planes. These are all integrated. But the most common integrated transport is actually walking and public transport. That's also integrated transport, or cycling and public transport. When I speak to the people here in Zagreb, in the city, they always say, "Oh, we need to have more cycling," and then they build a cycling lane which are 5, 7, 8 kilometers. They have plans to do this 25 kilometers cycle tracks, and they say it's in Amsterdam. No, guys, in Amsterdam, people have one bike cycling from home to the station, then they take a tram or train, metro, whatever, come to the city, have another bike there parked that they take for the last mile to get to their destination. And this is also integrated transport. And this is what we don't think about all the time, because integration is usually freight, less let's say public transport. Car, for me, it's a part of the solution, especially in rural areas. In rural areas, it is very hard, if not impossible, to organize a good public service of transport, because you have very wide population spread on a wide area. It's very hard to have a frequency of public transport, and your bus is full. So it is not a bad thing to have a car or any other modes of transport that actually brings those people to a hub, and then from this hub take them. We have cities here around Zagreb. You've probably all flown in from our airport. Everybody, I think 95% of people to our airport comes by car. The railway track is 500 meters away. If you measure on Google, you will see it's 500 meters away. But when we were building the airport, we didn't connect it. There is a city, the second largest city in Zagreb, called Velika Gorica. People are taken by bus parallel to the tracks, to the railway tracks, to the main station of the railway by bus. And when you think of that, something is wrong. And just the concept, the idea is that the road is more flexible is a problem. But yeah, we just have to think about it strategically. One of my thought that I wanted to share is, what is the problem? The problem, I think, is probably the politics, because when you build a road, and what Borna showed, you can do it in 4 years. You can plan it, secure financing, and build it in 4 years, which will make you, let's say, win the next elections. To change the transport policy, to change the way of thinking, it takes decades, probably a change of generation. And that's, I think, the biggest problem why we do. So in some country, it has to come to the point where it breaks down. So then people would change the mode. I always think about, you know, how in Zagreb we try to introduce is the first week of September, we have this mobility week, days without the cars. And then I think about the 1st of November, when in Croatia, in most of the Europe, it's a holiday where we remember our deceased, All Saints Day. In Croatia, traditionally, we go to the cemeteries on that day. And that's the day where most people in Zagreb use public transport. Why? Because it's organized in a way that it's convenient. It's more convenient to get to the graveyards with the public transport than it is with a car. And that's basically a mobility day in Croatia, not in September, if you think about it.
Thank you. But Adam, we have a mobility day in Hungary.
Yes, thank you very much for the opportunity. Yes, we have been, unfortunately, it's not the same days to go to the cemetery. But what I would like to draw your attention is that in the early 70s, in University of Vienna, Professor Knoflauer made a very interesting research. If some of you might know it, it's about travel time budget. He investigated a lot of countries all over the world with different societies, different economical backgrounds, and it's turned out, based on this investigation, that independently from the economies or the available technologies, people are spending 1.5 hours of traveling. So, and after that, a lot of researchers, decades later, repeated these research, and it's turned out that it's quasi constant in the last 5 or 6 decades. What does it mean for us, for traffic engineers and transport planners? I would say that it is something like that, that people are tending to traveling this 1.5 hours because they would like to reach some services, some goods that is not available at their own area. For example, working places, shopping, having leisure activities, or other things that is not available. And as in the last 6 decades, the technology has rapidly developed. We give people opportunity to go further in this 1.5 hours. So when we are speaking about, if you consider that nowadays we can have planes, very fast train services, that is increasing this area of activities to be reached. And this means that people are tending to have larger distances to traveling. Meanwhile, this so-called travel time budget is quasi constant. And what here is also very interesting, this integrated passenger transport is also playing an important role, because that means that these transport modes are connected with each other. And it is nowadays quite obvious that some people are traveling 100 and 150 kilometers away from, for example, from their home to their workplaces, and using 3 or 4 different type of transport modes. And it's quite amazing, I believe. So there are solutions where the integrated passenger transport are working. And as you ask what is happening in Hungary, unfortunately, it's not a good example, I must tell you. Thank you.
Okay, thank you. Well, and I will ask you something regarding that question, but maybe about this integrated.
Yes, just.
But I don't know how it's in the tourist destination when there is no possibility to make it, and the stakeholders and the cooperation with them to realize that. Can you say something about that, please?
I think that integrated transport is also very important for tourism destination, and especially what Marko said, walk, then take a public transport, then walk or cycle or something like that. So park and walk, cycle and go on. It is very important. There is a small difference between people generally in cities using integrated transport, and tourists, when they come to tourism destination, of course, price is always important. But people, when as tourists come to a destination, they have time. They have a little more time. They do not hurry so much. They do not go to work and so on. For them, it is important to be able to visit all the attractions and to use all the services, all the facilities, to have good connections between attractive points, accommodation points, resorts, hotels, and so on and so on. This is very important because this means that there is a possibility from the point of view of a local, local government, local community connected with traffic enterprises to organize integrated transport in such a way to manage these traffic flows. So by creating integrated routes of transport, so to say, for tourists, in such a way to connect, as I mentioned earlier, attractive points, accommodation points, restaurants, city centers, pedestrian zones, and so on and so on, you can, to some extent, stimulate tourists to use certain routes. So at the end, maybe if we speak about cities, towns, and so on as tourism destinations, you can, so to say, leave some routes from local inhabitants who go to work, to school, faculties, and so on, and canalize or stimulate tourists to use some other routes. So at the end, the existing infrastructure can be used in a more efficient way. So it is not, mobility concept is not always about money. Yes, it is about money. Without money, we can't, I don't know, arrange parking facilities for cycling, for small motor wheels. We can't arrange pedestrian zones. Of course, they have to be prepared if walking is to be nice for people and so on. But we can done a lot just using some organizational tools. So to point once more what was said earlier, we have to develop traffic for the future. I must say in Croatia we have a big problem with our tourists because the majority of them, as I mentioned earlier, they come by car. As we all are linked to our cars so dearly, we leave all our tourists, as they have arrived by car, they move around our destinations, but by their own cars. And we have, as Borna showed earlier on that strip, we have not happy, satisfied people who use flexibility, individuality, I don't know, social status, or something like that with their cars. But we have people staying in their cars, in streets for half an hour, 1 hour at, I don't know, maybe 35 or 40 degrees of Celsius during summer season. And of course, at the end, when we make research of their satisfaction in, while they stay in our destinations, when looking, I don't know, maybe 30 or 40 elements, they are very, very, very unsatisfied with traffic in our tourism destinations. They, of course, as I mentioned earlier, they say we do not have enough parking slots. Of course, it is not possible to have such huge parking capacities. They notice noise and so on, and they are, of course, not extremely unsatisfied with the public transport organization in our destinations. And just to finish and not to speak too much, we have made a research several years ago in Rijeka. We have several hotels, of course, lack of parking capacities, as I mentioned many times earlier. We asked tourists how important is for them while they stay at the hotel to have a parking place for their car. Of course, it is important for them, but what was very important, they say that they think it is not a big problem if they have the information earlier. So if they have the information earlier that there is no parking capacity at that hotel, we have such a hotel in the very center of Rijeka, where I live. So if they are informed earlier, furthermore, if they are given an information about public parking places, garages, parking fees, and so on, they think that it is a very good solution for them. So once more, just to finish, it is I think that speaking from our point of view of in Croatia, we have a problem with ourselves. How will we develop mobility concepts in our towns, destinations, and so on? I think that there is a future for paradigm which we mentioned earlier. So
okay, thank you. Well, now I think that we are near the time when we can give the talk to or the questions to the audience. But before that, I will just want to ask one question for each of you, because the conference named is E-Square Mobility. E-Square is the two words. E first, energy, that was the sessions before, and the E second is electronics, or better to say control. And now the question is regarding from the traffic engineers organizing, planning the traffic, how you comment the new technology of the electric vehicles and autonomous driving. Shortly, what is your view of these technologies? From the point of view, as I said, of the planners, of the organizers of the traffic, in short.
Okay, thank you. Quite difficult question. But okay, I think that by my personal opinion, the energy is the most important facts in transport today. So which kind of energy we will use and which sources we will use for produce this energy that we need for the transport. So I think this is a very important question. I don't have like straight answer for that. It's depending what we want to do. So maybe nowadays, the session before was about hydrogen. So there was very good tests with trains with hydrogen that are very feasible, very good, very cheap. So maybe depending what we want to achieve in some sectors, we can use different source of energy as we are doing today.
Regarding the energy sources, I completely agree with Bona. For the aspect of autonomous driving, I have a vision that in the future, one of these backbones of the system will be the availability of autonomous driving. I think that there could be some fleet operators, different fleet operators, offering different services, and you can be a member of this fleet and that fleet. I think the public transport service providers will always also be one of those operators of fleets. And then you can order the car or the vehicle you need at a specific situation. If you have to transport something, then a car where you can have space for luggage, for instance, and there can be smaller cars and bigger cars if you are a group or so. And the car itself knows when it has to go to the service, when it needs more energy, and so on. And what would this mean? That the private car ownership would decline? So there would be no, if those cars. I was when there was a time when we had no car, and I tried out to be in car sharing, and the problem was that when I needed one, no car was available nearby, and so we stopped that, and we thought that it would be good to have an own car again. That's right, it's mostly in the garage, but when we need it, it's there. And so I think if there is a reliable system and there is a guaranteed availability of the car, for instance, when you need it, then we can have such systems. And much space in the cities, which is now dedicated for the parking lots, will be free then and can be used in a different way, for instance, for cycling lines or for pedestrian lines or for whatever, planting trees, yeah. And I think this is possible. And would like to say one word, because Professor Knoflacher was mentioned, and the time budget, travel time budget. He, for I think 1 year ago or so, he published another study which is very interesting and could be a source of financing for public transport, because he said that when we build a new line of underground or rail or whatever, the costs are public, have to be provided by the general public. But so to say, the benefits are always private, because the premises, for the ground, the price for the ground, it's increasing hugely. And he said if there was a tax, a special tax, which you don't have to pay as long as you own this house or this place, but at the moment you sell it and you realize this benefit, you have to give something back to the public. I think this could be a considerable solution. Thank you.
Only in 2 words, because we are out of time a little bit. So
it was too long, sorry.
Only one sentence from the tourism point of view. I think that from here in Croatia, we have always more and more tourists coming by electric cars, and still not enough facilities to charge those cars, especially superchargers. So we must go on with that.
Very shortly, that the energy point of view regarding to your question, it's depend on what was the source of the electricity. So if we consider that in Norway, everything, every electricity is produced by renewable energy sources. Meanwhile, for example, in Hungary or in Poland, there is a lot of coal power plants still. So that means that the electric car can still have significant environmental pollution or contribution. Regarding to autonomous vehicles, based on our estimations and simulations, the fully autonomous and connective road vehicles could significantly increase the capacity of road infrastructure. Meanwhile, the transient, so until we reach the 100% of penetration of this technology, could be a huge problem when the human drivers and the autonomous vehicles are going to be both in the system. It could be a controversial situation, could increase the environmental pollution, and also could decrease the capacity of the road infrastructure. Unfortunately, I have to say it. Thank you.
Just few words. I know that you
just
can
few
speak
words.
up.
Yeah, I would like to speak a lot, but so 2 points. First point regarding the energy. I think the solution is probably diversification. There will be different sources and different ways of powering our mobility. But on the other hand, from the transport perspective, mobility as a service. In one generation, my grandmother, she needed to plant the seeds, to have the tomatoes, to buy the chickens, to feed them, to have the eggs. Our kids don't care about it. They go to the store, they buy it. We also do it in one generation. In next generation, they won't care whether the car is electric or hydrogen fuel or the option A or B. They just need to have a service from A to B. They don't care how they will get there.
Okay, thank you. Now we are short of time, but no questions regarding the time. The chairman said me sorry. Thank you, all of you, and thank you, audience, for your patience. And I'm closing this session. Thank you.
Okay. Am I online? Yes, I am. Well, ladies and gentlemen, as we come to the end of this remarkable conference, I want to extend my heartfelt gratitude to all of you for making this event a resounding success. Your enthusiasm, knowledge sharing, and dedication have truly enriched these past few days. It doesn't sound a lot like me, does it? Because it's not me, it's cheat GPT generated. Me, myself, I just want to say that I hope that you will find, well, the organization acceptable, our company bearable, and the food sufficient and edible. I am sincerely thankful to our head of organizing committee, Neven, and his team from SDEVES, who really made this possible. Without his help and the professional organization, this event would be much less of a success. A friendly advice to Mika, the effort required to successfully organize such an event and to cover all possible situations that arise, including the last-minute cancellation of keynote speakers, is considerable, but I'm positive, I'm certain that Mika will not underestimate that. I'm, well, very much looking forward for hosting you again in 33 years here. That is, if no new academies join CAETS in the meantime. I just want to remind that the sightseeing of the town, guided sightseeing, guided tour starts at 3:15 in front of the hotel, and that at the same time the council will commence here in this room. So Mika, please, the floor is yours to present the next CAETS annual conference in Helsinki. Thank you.
So, dear colleagues, ladies, gentlemen, thanks on my behalf of the opportunity to present the next CAETS 2024 conference, which will be held in Helsinki in July next year. My name is Mika Hannula. I'm a chair of the Finnish Academy of Technical Sciences, and there will be two main organizers for this conference, not only our Finnish Academy of Technical Sciences, but also the Council of Finnish Academies, consisting of 4 different academies. And now you are wondering why we have this kind of a council consisting of 4 different academies. Well, this is an interesting story because Finland is a bilingual country. We have a Swedish-speaking minority, about 4 or 5% of the nation. So when it is the case of this kind of, should I say, traditional organizations, we have Swedish-speaking academy in technology, and also the Finnish-speaking academy in technology. And then we have traditional Council of Science and Letters, and also the counterpart in Swedish. So that is the reason we have 4 different academies behind all this Council of Finnish Academies. So the topic of the conference will be carbon-free technologies and society, including following subtopics, but not limited to these: technology, industry and society, agriculture and forestry, social and economic impact, and the European Union and global perspectives. And here you can see the preliminary program of the conference, consisting of 4 days. On Monday, the 1st of July, in forenoon, we have committee meetings, in the afternoon, board meeting, and then in the evening, the cocktail reception provided by the city of Helsinki. On Tuesday, the 2nd of July, in the forenoon, we have the official opening ceremony, as well as the keynote speeches, and in the afternoon, we have 2 parallel sessions, or maybe streams of sessions, namely the scientific and at the same time technical symposium or session. And then at the end of the afternoon, we have booked time for the CAETS Communication Prize, of course. And in the evening, there will be an optional visit to the Suomenlinna Sea Fortress, and well, there will be a small fee for this, and the number of visitors will be limited, unfortunately. I will tell you more in a minute. And on Wednesday, the 3rd of July, in the forenoon, we will continue with 2 parallel streams of sessions, namely scientific and technical symposiums. And in the afternoon, we will have a series of panel discussions, official closing ceremony of the conference, and council meeting, of course. And in the evening, we have the official conference dinner. So it is the program of Wednesday. And on Thursday, the 4th of July, we have optional tours to 2 very, should I say, international, interesting places or companies to visit. I will tell you more about this later. And here you can see the basic parts of the social program. The cocktail reception it will be held at the City Hall, hosted by the city of Helsinki, the capital of Finland, as I told you earlier, and this will be included, of course, in the conference fee. The optional visit to the Suomenlinna Sea Fortress, which is actually one of the UNESCO World Heritage Sites, on Tuesday, will need a small extra fee. I don't know the amount of the fee yet, but it will be probably be something between 30 or 40 euros, I would guess. And the conference dinner will be, of course, included in the conference fee, and it will be arranged in so-called Vanha, the old student house in Helsinki. And as I told you earlier, there will be 2 optional tours hosted by Neste and Expand Fiber. And I think there's a small error on the slide. No, it's Thursday, 4th of July, that's correct. And the fee will be something maybe between 30 or 40 euros. We don't know the exact amount yet. And unfortunately, the number of participants will be limited. And about these companies, Neste is actually a very well-known fuel company in Finland. And the other one, Expand Fiber, is not actually a company. It is an ecosystem consisting about 30 or 35 different players, namely Finnish companies operating in the international market, as well as universities and research organizations. And now, in order to give you just the right exact information, I will read what I have here to say you about these 2 targets. Neste is the world's leading producer of sustainable aviation fuel, renewable diesel, and renewable feedstock solutions for various polymers and chemicals industry uses. They are also developing chemical recycling technologies and capacity to combat plastic waste challenge. The ambition is to make one of the refineries, namely Porvoo refinery in Finland, the most sustainable refinery in Europe by 2030 and to reach carbon neutral production by 2035. And this is a how should I say it, a fuel company, and they production plant. So I personally find it really interesting how they will make the production sustainable and carbon neutral by 2035, but maybe we will hear more next year. And Expand Fiber, as I told you earlier, is a business ecosystem. It is an R&D collaboration and ecosystem launched by two major forest companies in Finland, Fortum and Metsä Group, to accelerate the development of sustainable bioproducts. It focuses on upgrading pulp fibers, hemicellulose and lignin from renewable and sustainable sources of straw and northern wood into new bioproducts. Its ambition is to meet the growing demands for sustainable textile fibers and other added value biomaterials. So these two will be the places we will visit in July in Helsinki. Okay, the venue for the conference will be the main building and the central campus of the University of Helsinki. And actually, the University of Helsinki was established 1640. It is one of the three oldest universities in the Northern Europe. The location is very central in its nature, and it is located at the old historic city center of Helsinki. And let's check this slide next. The accommodation will be arranged in nearby hotels on walking distance, something between 200 meters or 1 kilometer from the University of Helsinki, so it's quite a convenient location for all of us. And we will, of course, arrange conference rates for 3 hotels near the venue. And then let's go back. The registration fee will be 290 euros. There is a little bit more what we had here in Zagreb, but this is because of the higher overall cost level of the Northern Europe. So I apologize this one. Registration and payment deadline will be the 12th of May 2024, and we will do our best that registration is open from the beginning of April. Let's see what else I should tell you. Yeah, by the way, the conference pages are already open this week. www.caets2024.org. And of course, we will put more information on the site as soon as it is possible. But there should be the most important information already available. And then a couple of words about Finland. We are nowadays a NATO member. We have been a member of the European Union for a long time now. Population is only 5.6 million persons, and the capital is Helsinki, as I told you earlier. And we have 2 official languages, Swedish and Finnish. And but you don't have to speak Finnish or understand Finnish fluently if you visit Finland, because practically speaking, all the Finns speak English at least a little bit, and all the necessary services, hotel accommodation, restaurants, service is available in English, so you should not worry. A couple of words about our economy. Of course, service sector is quite strong, but manufacturing and refining, including electronics, machinery, vehicles and other engineered metal products, forest industry and chemicals are also important for us. And according to the latest studies, perhaps you knew this one, since 2019 we have been every year the happiest country in Finland. To be frank with you, sometimes it is difficult to believe, and I'm discussing with my colleagues on Mondays, but well, maybe scientists know what they are doing, and we are the happiest country in Finland. And another fact is that Finland is the second least corrupted country in the world. And us, I mean Finns, we trust the following institutions very strongly. First, universities, then police, then the Finnish Defence Forces. This is the same three institutions every year we find in our studies when you ask which are the most trusted institutions in Finland. The weather is quite nice, mostly. On July, temperature is quite warm. It may be even 23 degrees centigrade, but usually it is something like 20 or 22, so you don't need your winter jackets. There's no polar bears in Finland. And one important fact for you, if you have not visited the Nordic countries before, in July the nights are white in the country. So if you are not used to that, I strongly recommend you to use the curtains of your hotel room to make the room as dark as possible. You don't see the midnight sun in Helsinki and in the southern part of Finland anyway, but the nights are quite white. How to get to Helsinki? It's easy. The main airport of Helsinki is located about 20 or 30 minutes from the city center. And of course, there is a lot of direct long-haul routes from and to Asia, Middle East, North America, not to mention the other countries of Europe. And if you prefer ferries, I mean boats, there are direct boat connections or ferries from Estonia, Poland, Germany, or Sweden. So maybe it's possible to have a vacation in the Northern Europe at the same time if you wish to. So, dear colleagues, ladies and gentlemen, it's my pleasure to warmly welcome you all to Helsinki next year. And here you can find the contact information to me. But of course, I'm a full-time vice director for our university, being in charge of partnership strategic engagement. So being a chair in this Finnish Academy of Technical Sciences is only a position of trust. But Arto Miettinen is the Secretary General of the Council of Finnish Academies. So, but we are both happy to answer your questions. Of course, when it comes to traveling other practical issues, there will be the contact information on our website. So, ladies and gentlemen, thanks for your time. And if there are any questions or comments, I will do my best to answer. No questions, no comments? In fact, pardon? Thank you. So, see you in Helsinki. Thank you.
Ćemo na Zoom. Da.